Right, okay. We are ready to roll. Can you install? Okay. Right. Okay, can you believe it? We're at week 9 already. Hey, what does that mean? How much, like, after this week will be what? Well, yeah, week 10, but I'm just trying to think. We're like
I got that mad.
we're like 2/3 of the way through the semester or something, right?
Just a couple more weeks.
Yeah. So, okay, so let's go ahead and get started. So this is week 9. So just to review kind of where we're going for the rest of the time, because we are, the syllabus has changed a little bit over the course of the time. We've cut some stuff out. So this week we're doing longitudinal. I've got 2 examples I want to show you. The first one, it really has to do with thinking about centering again, but thinking about yay, centering. Group mean and grand mean centering of time varying covariates. So we're going to talk about that. And then that's actually what your homework assignment is, a centering assignment, thinking about group mean and grand mean centering covariates for homework. And then the second example is actually modeling discontinuity, which is fun. We'll talk more about that when we get there. And then next week, that is fun. I like that. This is one of my favorite examples, actually. And then next week, we're going to do piecewise and polynomial models. So piecewise models, you'll see there's a lot of similarity to what the second example today. They're, highly related. But we'll take it further, and then we'll do polynomial growth models. So we'll do quadratic and cubic growth models next week. And then after that, so that's the end of week 10, right? So then that only leaves 4 weeks, I think, when we finish longitudinal. So the big things on the docket after that are to talk about residuals. We'll probably talk a little bit more about error covariant structures. We'll talk about residuals. And that will probably take us to Thanksgiving break. And then after Thanksgiving, there are 2 classes left. The first class after Thanksgiving is all about power, sample size, and design issues. So I'll show you how to run power analyses for different kinds of multi-level models, which I think is super useful. And hooray, we're not going to do that in R. I'm going to show you some power analysis freeware programs that will allow us to do the power analysis. I mean, you can do power analysis in R, but I'm going to show you some standalone power analysis software that's available out there that a lot of people use. So we'll do that on week, 13, right? And then the final week is actually a review for the final exam. So, we'll review some things and you can ask questions. And then the final is during exam week. So my gosh, it's happening. We're moving through. Okay. So on that note, let's get started with our example for this week. Did everybody get? I didn't get, but I'll take packets. All right. Thank you. This is excellent. Okay. So this data set that we're going to be, I don't think exactly. We're doing the time varying covariates first. So this data set that we're going to be talking about right now, we're actually going to use the same data set next week when we talk about piecewise and polynomial models. So we're sort of remember the setup. And I feel like at some point we talked about this data set a little bit. I don't remember why, but we didn't actually do anything with it. So I don't remember why I talked about it. But just to refresh your memory, this is the NYS data set. I think I used it as an example maybe when I was talking. So what we've got here are attitudes toward antisocial behavior is the outcome variable, and these are kids, adolescents who are measured 5 times. It's time structured data, by the way. So they're measured at ages 11, 12, 13, 14, and 15. So there are 5 measures across 5 time points from ages 11 to 15. And they're being asked about sort of antisocial attitudes, like their attitudes about antisocial behavior. So that's the outcome variable. And obviously time is going to be an independent variable in the model, right? So how do you think attitudes toward antisocial behavior might change across time in adolescence? Are they going to increase or decrease or stay the same? What do you think? Anybody? I was going to say, as a mother of two teenagers, I'm going to say increase, right? Attitudes toward antisocial behavior and that's what we're going to see. It's going to be a positive. It is going to be a positive slope. So attitudes toward antisocial behavior tend to increase across time. And then we've got this time-varying covariate, which is exposure to antisocial peers. So how, what's your peer group, and and you could sort of think about it, what are the attitudes of your peer group, right? Are you hanging out with the honor students? Are you hanging out with the delinquents, the troublemakers, right? And then, obviously there's kind of an endogeneity problem here. This is not causal inference class, but if you think about it, it's sort of which came first, the chicken or the egg, right? Are kids who are more antisocial sort of, are they gravitating toward the more sort of the tougher peer group, or is it the fact that they happen to be hanging out with the tougher peer group that's making them more antisocial? Again, that is not a question that we are prepared to answer with our multi-level models. We don't know. We can only really talk about relationships and prediction. But be that as it may, it makes sense that we might be wondering, okay, I want to look at attitudes toward antisocial behavior from 11 to 15, but I also, I know what kind of peer group they're hanging out with. I know that, and so I might want to control for that, or I might want to be looking at, how does that relation, how does exposure to antisocial peers, how does that also predict antisocial attitudes from ages 11 to 15? So that's the basic sort of setup of the model. Does that make sense? Okay. So far, let's see, we've done time-varying covariates, and we grand mean centered our time-varying covariate, right? But just like we talked about when we talked about organizational models, and we have a variety of choices in terms of how we could, and I think I talked about this when I first started talking about time-varying covariates. I sort of alluded to this and said that we would come back to it. So now here we are. We're back to talking about this issue. So if you think about how would you maybe want to center your time-varying covariate, there are a variety of options, none of which, honestly, in my opinion, are completely satisfying. They all are, nothing seems perfect, but maybe some options are better than others. So our first choice would be we could not center the variable at all, right? And actually that does make sense in some circumstances. So for example, when we had our unemployment example last week, right? We had job was a time-varying covariate, and it was dichotomous, and we didn't center it. It was dummy coded, but we didn't then center it. It was just a 0-1 variable. By the way, you can center dichotomous variables. There's nothing that says you can't center dichotomous variables. We didn't center that dichotomous variable, but we absolutely could have. And if we group mean center a dichotomous variable, we're generally going to want to do the same thing that we do with continuous variables, and we'll want to add the aggregate of that group-centered dichotomous variable back in at level 2, which would be the person level here. So you could do that, but I would say, of all the variables that often end up remaining uncentered in both regression models and multi-level models, dichotomous or categorical variables, which are already coded in such a way that 0 is interpretable, are probably some of the variables that are most likely not to end up getting centered, but to be used in their sort of uncentered, although I guess not, uncentered, but already sort of coded form. Okay, so that's one option. We could add the variable uncentered. And again, some continuous variables, it might make sense to add uncentered under certain circumstances. There isn't, with many things in multi-level modeling, but especially with centering, there isn't a one-size-fits-all answer. Under every circumstance, you should always do it this way. I think there are some serious pros and cons to different techniques that we're going to talk about. But having said that, when you're doing your own data analyses, you really need to think about, you know, how do I want to center? Why do I want to use this centering technique? And am I going to be able to, you know, adequately and accurately interpret my parameter estimates? And that's super important. Okay, so uncentered is option one. Option two would be grand mean centered. And I think we had an example, well, I guess for homework, your example was grand mean centered, the continuous covariate, right? And I'm trying to remember what our example was last week. Unemployment, what was our job? So we only had one that was dichotomous, right? So we didn't have there wasn't a continuous one, but there is a continuous covariate in your homework, right? And it's just grand mean centered. So that's another option. But remember, what do you remember about what we said about grand mean centering level 1 covariates versus group mean centering and adding the aggregate back in at level 2? Think back to our organizational days. What are sort of the pros and cons of those approaches? Do you remember? Did you say smooshed? Yeah, remember we talked about this idea that when you put in the covariate as grand mean centered, just at level 1, the variable has both within and between variance. I mean, this is the really sort of important point. There's both within and between variance in that variable. How much within and between variance depends on the variable, which again is another consideration for when you're deciding how you want to center something. You probably want to know how much within and between variance there is actually in that level 1 variable that could potentially play into your decision about what centering decision makes sense, and certainly plays into your decision of understanding how this variable is going to operate. Because if a variable is 99% level 1 variance, right? If it's like 99% existing within cluster or within person, what does that tell you? That tells you, okay, yeah, this is a variable that varies within person, but there isn't a lot of between person difference in that variable, right? In the most extreme circumstance, if all of the variance were within person or within cluster and there were no between person variance, that would be a situation where you could actually group mean center a variable and not add the aggregate back in at level 2. Why? Because there's no between person or between cluster variance to explain, right? So if you had an ICC of 0 on your time varying covariate or on your level 1 covariate, and this is again, you never get an ICC of 0 or 1, right? And it's sort of stylized, but if you had an ICC of 0, I mean, I shouldn't say that actually. I mean, there could be a scenario like you could imagine time, for example. Think about our time variable. I mean, time is a time varying covariate, right? If you think about it at a very deep level, time is the quintessential time varying covariate. I tend to think of it like, when I say time varying covariate, I'm usually thinking variables other than time because, like, again, it's a growth model. So it's kind of a duh-he. It's a given that we're going to have time in our model, right? And I usually think about coding time separately from coding these other time varying covariates. So usually when I say time varying covariate, I'm really thinking other variables besides time. But for now, let's think about time as a time varying covariate because it is. So imagine you have a balanced design, okay? So everybody's measured at the same number of time points and there's no missing data or anything. So let's say, which is kind of what we have in this example. So everybody's measured across 5 time points and we code it 0, 1, 2, 3, 4, and everybody's got all 5 time points, right? How much between cluster variance would there be in that time variable? Think about it. Yeah, think about it. If you 0, right? Because think about it. That's exactly right. Because think about it. Imagine if you have 0, 1, 2, 3, 4. Right? 1, 2, not hard math. 0, 1, 2, 3, 4. What would the mean be for a given person? like 2, right? I think I did that. Yeah, okay. Hard math this early in the morning. So the mean would be 2, and the mean would be 2 for every person in the sample, right? Because that's why I gave the caveat up front that like we have like it's balanced data and we don't have any missing data, because technically like as soon as somebody's missing time point 4, you're not that person's mean isn't gonna be exactly 2 anymore. And so now there's gonna be this infinitesimal amount of between cluster variance, although I would argue, even though it's not technically exactly 0, it's still pretty trivial. But in this stylized example I gave you, the between cluster variance in the time variable is actually 0, right? So I don't need to think about like adding the aggregate of time back in at level 2. And in fact, if you tried to do that, the computer would probably be like, I can't do this, right? Because you'd be feeding in at level 2, the covariate would not vary across people. So it's what I like to call, well, in SEM, I call that a latent constant, right? This isn't latent, this is observed, but I always like to joke about, latent variables, but they have to vary, right? So this would be a variable that doesn't vary. You can't have a variable that doesn't vary. It's just a constant, and you can't feed a constant into your models or bad things will happen, because that doesn't make any sense, right? So there could be, so time is actually an example of a time varying covariate that has no between person variance. There could be other variables that you have that are actually within person that truly don't have any between person variance. Or they could be within cluster and they truly don't have any between cluster variance. So for example, let's say I'm doing a study and I have clusters of 10 people. So there are exactly, again, I'm going to make it exact, make the math nice. So there are exactly 10 people in each cluster. And I randomly assign 5 people to treatment and 5 people are in the control group. And people are assigned not by cluster, but within cluster, right? Which is what's called a multi-site design, by the way, rather than a cluster randomized trial. So in that case, if I have 5 treatment and 5 control in each one of my clusters of size 10, it doesn't really even matter how I code that variable. If it's dummy coded, if it's 0, 1 dummy coded, what would the cluster mean be for treatment? If there are 5 zeros and 5 ones. 0.5, that's right. If I put in 5 1/2 and 5 -1/2, like I suggested before for effect coding, what would the cluster mean for every cluster be? 0, right? If I put in 5 1s and 5 -1s, which is a dumb way to effect code, what would the cluster mean be? 0 for every cluster. So that's another classic example of like, if you were within cluster, you were assigning people to treatment and control, and you had the same number of people assigned to treatment and control, or even the same proportion. Doesn't even have to be the same number if you think about it, right? Some could be 8-person clusters, 10-person clusters, 12-person clusters, and 20-person clusters. And as long as I randomly assign the same proportion of people to each cluster, to treatment and control, then when I take the mean of that cluster, I'm going to get the same thing across all of my clusters. So that's another perfect example of where you could have a within cluster variable where you could group mean center, right? I mean, again, effect coding is basically, in this case, like group mean centering, right? You can group mean center and you don't need to add the aggregate back in at level 2. But if you think that there's going to be variability at level 2 on this time varying covariate, whatever it might be, then that's a situation where obviously you sort of need to, if you want, well, maybe you should always want to, but if you want to think about partitioning the variance in that time varying covariate into the within cluster variance and the between cluster variance, or in our case, because we're talking about people, it's longitudinal. But again, these things generalize back and forth. I hope you're starting to see how everything we do in longitudinal, it fits with organizational and vice versa, right? It's just a different application. So if we want to look at within person variance and we want to partition out the within person variance and the between person variance in the time varying covariate, then that's a place where we would want to center within person and then add the person mean back in. And there are lots of examples where you could, you could think of lots of examples in the social sciences where we might think that there's both within person variance and between person variance. And again, that might sort of, those things are, I mean, obviously you're taking one variable and you're partitioning it into these two pieces. So they're obviously, well, they are unrelated actually, the way that you partition them. They're orthogonal, but like there are lots of scenarios where I think we think that way theoretically. So let me give you a couple of examples. Let's say that we're measuring somebody's anxiety. Let's say anxiety is our time varying covariate. And you could imagine that, and we're looking across time, and you could imagine that people's level of anxiety varies across the time points that I'm measuring, right? So some days I might be feeling more anxious than other days. Right? So imagine I have an overall average on my anxiety, right? So everybody, you could take their own sort of, think of it as like there's some homeostatic, right? Some level of anxiety that every person has. Those levels are going to be different. Whoops, that's the between person variance. But there's some homeostatic level that I have for my anxiety, or stress. Stress is probably even better than anxiety because it probably varies more actually across days within person. But so here's my level. And then, right, I'm measuring anxiety on each of these different days, and my anxiety level is not staying constant. It's varying across days. If I group mean center, then I'm really looking at just, okay, how much is my anxiety higher or lower than my own personal average, right? How much is my anxiety higher or lower than my own mean, or stress, right? How, like, some people probably live a more stressful life than others, but like some, what might be more salient in some sense, or again, both things are salient, they work differently, is how much stress I'm under as compared to like my average amount of stress, right? So that's sort of this idea of looking within person. And if we group mean center, so if we person mean center, then if we take anxiety and we person mean centered, then that person mean centered variable is really just telling me about the person's deviation from their own personal mean. Are they more or less stressed than average? Are they more or less anxious than average, right? But just like in the examples that we did for organizational examples, if there's between person variance and anxiety, and I think this is a perfect example because you could imagine that even though there is within person variability, some people are more anxious than other people, right? For sure. Like so there's like a state like, in psychology, we often talk about like states and traits, right? So we're saying like there's some state-like component to anxiety that under certain circumstances and certain contexts that are going on, you might be more anxious than other contexts. But there's also a trait-like component to anxiety too, in the sense that some people are just more naturally anxious than other people, right? And so the between person variance in anxiety is really capturing the between person that's really capturing how different are people in terms of their average levels of anxiety. And if I just group mean center and I don't add that aggregate back in at level 2, then all I'm looking at is like how you deviate from your own mean, but I've lost any of the information about your mean and how that might affect things. Yeah. Yeah, that's adding in. So what we do, when we create the group mean centered variable, to create it, we always have to create the person's mean or the cluster's mean, right? And then we take each of the scores and we subtract out the cluster mean. But we have this cluster mean. And so it's that cluster mean or person mean, it's longitudinal, that we already have available, that we've already had to create, that we're then going to add in at level 2 as a level 2 variable, as a level 2 predictor. Right? And you can totally imagine that you could imagine that there might actually be differential relationships between the level 1 variable and the outcome and the level 2 variable and the outcome, right? So it might be that, now I need an outcome, but like, let's say it's stress and Sleep. Okay, stress and sleep, sure. So, so let's say that within person, it could be that the more, this is kind of a weird example, but like the within person, let's say the more stressed I am, the less, I don't know, the less I sleep, let's say. But maybe on average, like people who have more stressful lives, maybe they sleep. I mean, I don't know if this is not a great example, but because maybe you don't buy that, but maybe people have more stressful lives, maybe they do sleep more, right? I don't know. They probably don't, but but you get.
They hate it. They hate how much they're sleeping.
Yeah. But you know, but you or how about like uh, productivity? I was gonna say like some people do sleep more. Yeah. Well, and there's but there could totally be a differential relationship between like the group mean centered variable and the outcome and the actual like cluster variable and the outcome, right? Those things don't have to actually work in the same direction. And remember, we talked about contextual effects. So, or they're sometimes called contextual, sometimes called compositional. So don't let that throw you, but contextual or compositional effects. So who remembers what a contextual effect is? Well, it's like we've got this variable at level 1, and we've got the effect of the variable at level 1, right? The within effect, let's say. So let's say we've group mean centered. So we've got the within effect of the covariate on the outcome variable, and then we've got the between effect of the variable on the outcome variable, right? And if there are no contextual effects, if we say there are no contextual effects, that means that that basically the effect of the variable on the outcome is the same at the within level as it is at the between level. That's no contextual effects. So that's like saying the variable operates, again, let's go back to my stress sleep example, because it's probably a better example if you could imagine. Maybe there are no contextual effects for the effective, maybe for this effective stress on sleep. So maybe at the within level, the more stressed you are, the more you sleep, and at the between, or no, sorry, the less you sleep. The more stressed you are, the less you sleep, and maybe at the between level, the more stressed you are, the less you sleep. And it's not just that they're both positive, that means that you have no contextual effects, but they're positive and they're of the same magnitude, right? So basically that relationship, that predictive effect is the same across levels. So it's operating in the same way. Yeah, question. So that's exactly right. So no contextual effect is that they're the same, and the contextual effect is the difference, right? So it's like you can imagine it's like the between effect minus the within effect, right? So that is the contextual effect is the difference. So they, again, so both effects could be positive, but there could still be a very large contextual effect because it could operate much more strongly at the within level than the between level, or the between level than the within level. Okay, why do I bring this contextual effect thing up other than the fact that it comes up on your homework again this week? But also, this is one of the cases where, like, if you don't have contextual effects, if the variable operates the same way at the within level as it does at the between level, that's a place where it's far more defensible to just grand mean center the variable at level 1 and put it in the model. Because if you don't take the variable and break it out into the two pieces, you are actually, you don't realize it. You see, this is the thing. There are all these assumptions that we make that are undergirding all of the way that we do our analyses that we don't always make super explicit. So if you just stick in that variable grand mean centered, what you're saying is there is no contextual effect because you're not allowing for the contextual effect, right? Because you're only going to get one effect of the time varying, again, it doesn't even have to be time varying, that level 1 covariate, there's only one effect of that time varying covariate on the outcome variable, right? You're just going to get that one coefficient. So, and you know that this variable is a combination of within person variance and between person variance, but you haven't partitioned it out. So you haven't partitioned it out, and you're just saying, and what you're saying is, okay, I don't need to partition it out because I really think that this variable is going to operate in the same way at the within level as it does at the between level. And so putting it in as a level 1 variable, yeah, it's going to explain some within variance. It's going to explain some between variance. I think that effect is going to be the same. I think it's going to work in generally the same way at both levels. That's fine. So I just need it as one, level 1 variable, and I'm going to grand mean center it so that I can actually interpret my results, right? And if you're right, again, if there is no contextual effect, that's a much more sort of reasonable way to do the model. But if you're wrong and there is a contextual effect, then your assumption is wrong. And then obviously that's when you're going to get these conflated effects, right? Where you're not, or smushed effects, right? Because basically what you're doing is you're smushing together the level 1 effect and the level 2 effect, but it's not a simple average because you always have sort of more data at level 1 than you do at level 2. And it's a function of the variance, it's a function of the sample size at the different levels. So it's not like you could grand mean center something, look at the smushed effect and just be like, well, I mean, you couldn't do this anyway, but be like, oh, I bet it's, you can't sort of like backpedal easily and say, oh, it's probably, now that I've done this, I can figure out what it should be at each level or whatever. And then there's no like easy mathematical way to sort of do that exactly. So if you think that there are contextual effects, so number 1, if you think there are contextual effects, or number 2, if you're interested in really looking at the between and the within parts of that variable separately, which again sort of suggests you probably think there are contextual effects if you think about what a contextual effect is. But if you really want to sort of think about the within part and the between part, that's when you're really going to want to group mean center and add the aggregate back in at level 2. So questions about that before we kind of get into the example? Yeah. Oh yeah. So everything that I've just said only applies to level 1 predictors, right? Which in this case would be time varying covariates. And in the organizational case would be like just a level 1 person level predictor. If you have a level 2 variable, and let's assume we're only talking about a 2-level model, because if you have a level 2 variable and it's a 3-level model, then you do this whole thing again, but we're not going to do that right now. So if it's a 2-level model with that level 2 variable, you cannot group mean center, right? I mean, think about it. It's that if you got a variable and it's at the person level, like high school GPA. Thank you. So it's college students and it's high school GPA. So there's no way to partition that variable into within person and between person variance. Now, if you had high school GPA across every semester in high school or something, you could do something. But if you just have overall high school GPA or SAT scores before they head into college, right? That's a person level variable. Now you need to think about how do you want to put it in centered or uncentered? By the way, what if you didn't center SAT score and you put it in your model? What would your intercept be? I don't know, but it would be very negative, right? It would make no sense. Think about that. Like, it's a perfect example of you better center. You can never use SAT score uncentered, because remember, SAT scores are like you can't have a 0. It's like 200 to 800. So you put an SAT score uncentered, right? You're putting in a 0. That is like so extrapolated beyond the range of your data that it's like, what the heck is that? Your intercept is going to be so meaningless, right? So you would have to center SAT score, but you would have to grand mean center it, right? Or another option that we haven't talked as much about, but you could, what's another option for how you could center SAT score if you didn't want to grand mean center it, but you wanted it to be interpretable? Let's just think we're taking one subject area, by the way, not the total test. So like 200 to 800, and what's the mean for each subject area? Well, it's supposed to be 500, right? I don't know, it varies and they have to recenter and stuff, but let's say they've just recentered, so it's 500 again. So what would be another logical thing? You could center your SAT variable rather than around your sample mean. You could center SAT around 500, which is the population mean or the national mean. Again, nothing wrong with that. It might make real sense for you, given the data analysis that you're doing, right? Or it might not, you know? So sometimes people might choose not to center around the actual sample mean of their variable, but they might choose to center around like a population, like a known population mean of their variable, or a known value that is super important. Like this is the number, let's say it's some sort of a test for, I don't know, licensure or something. This is the value you need to have on this test in order to become a doctor. You know, less than that value is failing and more than that value is passing, right? And you could imagine, again, depending on the context of your study, maybe that's the place you want to center. Maybe it's not like the mean of everybody in the sample, but it's like the point at which, you know, something changes. So the cut score, exactly. So these are all possibilities, but those are all possibilities at level 2, but you cannot group mean center at level 2, right? At the highest level, your options are don't center, grand mean center, or center around some other value that makes conceptual sense to you and makes 0 is like where 0 is interpretable. So, I mean, I would hope that if it makes sense to you, that 0 would be interpretable, but I guess I'll just throw that in there just in case you have an idea where it makes sense to you, but 0 still doesn't make sense. So, you know, those are your options. But yeah, you can't group mean center at level 2. Okay, so what was is that not your question? What was your question then? Mm-hmm. You understand the question?
Like, I think, so she wants to know if it's just a level 2, tell me if I'm right. It's just a level 2 variable and there's no level 1, like, to go with it,
Mm-hmm.
and you have a contextual. Is that what you're asking? Yeah.
See, I feel like this is a semantic question. In the way that I was describing contextual effects, like just now, as a sort of a mathematical thing, then I would say no. But where it gets tricky and where maybe you're confused is that we often refer to level 2 models as contextual models and level 2 effects as contextual effects, in that they are the effective context, right? So like, so I think it's a case where we use the word contextual to really mean it really has to do with level 2. When we talk about contextual effect the way I was just talking about it, we're really talking about the difference between, you know, or that's also why probably it's called compositional effect as well. We're really talking about the difference between the level 1 and the level 2 effect. But I guess at a deep level, now that I'm talking, in some sense, if it's only a level 2 variable and we call it a contextual effect, which we do, in some sense, it can only be contextual, right? Like you don't need to actually partition out the difference, right? So it only operates at the contextual level if it's a level 2 variable. So people do refer to those as contextual effects. I've never heard them referred to as compositional effects, but that I think is really just for the difference. But yeah, so the effective context is that level 2 effect, but there's no way you can't partition it out. There is no difference. It's just like, this is the effect of the level 2 variable on the intercepts, randomly varying intercepts. This is the effect of the level 2 variable on the randomly varying slopes, right? Yes. Mm-hmm. That's right. Yes, I should have said that more explicitly, but yeah, as soon as you take the aggregate of the variable is a level 2 variable, right? The variable is a level 1 variable. So the original variable is a level 1 variable. And if I grand mean centered, I just have one level 1 variable, grand mean centered, and that level 1 variable is likely some sort of mix of between and within cluster or between and within person variance. If I group mean center the variable, I've now created this within variable, and when I take the aggregate, that is a level 2 variable, right? It is a between only variable. So that's right. So basically, what you're doing when you group mean center is you're taking one variable that you think varies both within and between. You think there's level 1 variance and level 2 variance. If you don't think there's any level 1 variance, then it should be a level 2 variable. And if you don't think there's any level 2 variance, then it's still a level 1 variable, but you don't need to add the aggregate back in at level 2, right? So, and actually on the homework, one of the questions that I ask you at the beginning is to compute just compute, report, and just say something brief about the intraclass, like a sentence or less, about the intraclass correlation coefficient for the time varying covariate. And the reason that I'm asking you to report and interpret the intraclass correlation coefficient for the time varying covariate is because, again, it's a really good practice for you to do when you're modeling your own data, because if you run that ICC and it's 0, right, then you could group mean center, but you don't need to add the aggregate back in. If you run that ICC and it's 1, then it's not really a level 1 variable. It should be a level, you think it's at level 1 because you've got something at each time point, but really it's not varying within person, it's only varying between person. And then just sort of looking at where it is in that space, I think is kind of helpful to get your head around. I mean, you're not going to do anything per se, but like, here's this variable. What proportion of the variance in this variable is within person, and what proportion of the variance in this variable is between person, right? Because if I'm going to, again, if I'm going to use this as a time varying covariate, it's good to kind of have a sense of, is there a lot of variability within person, but not very much between person? Or is there a lot of variability between person and not very much within person? Or is it just kind of like there's a lot of each? There's a fair amount of within and between person variance. I think that's like a helpful thing to look at when you're, starting to model a time varying covariate. Yep. Was treatment level 1? I thought treatment group was a level 2 in homework 5. I thought you only had time in yeah. But I mean, yes, so it was at level 2 in homework 5. I didn't give you, it was only time invariant covariates in homework 5. You had time was the only time varying variable. And then you had treatment, attitudes towards school or something, attitudes towards something, I think it was school. And then the interaction. All of those things are at level 2, right? Like, so you've got 2 level 2 variables and their interaction, and then those level 2 variables can predict the randomly varying intercept, and they can also moderate the time slope, right? So they can also predict, like they can also be predictors of how the time slope varies. But they are all level 2 variables. But you could have, treatment could theoretically be a within person variable. Like there are studies where, for example, classic example of a within person study would be single subject studies in school psychology, right? Where now, usually, sadly, who here's in school psych? Anybody? Okay, I was gonna say, anybody here school psych collects at least 30 people in a single subject study, I'll be on your committee gladly. Because then you could do multi-level modeling. It would be so much fun. But anyway, the sad thing about single subject studies is that they're often like 2, 3, 4, 5 people. So that's not very many people for a multi-level study. But in a single subject study, what you do is you get baseline data on a person, right? And then you intervene and do something, and then you collect the data after post-intervention. Sometimes you go back to baseline or whatever. There are lots of different versions of those studies. That's a within-person study. So you can absolutely, there can be treatment can vary within person. I feel like in some lab studies that they do over in the psych department too. Don't they do like within-person manipulation sometimes in certain lab studies where like a person comes in and whatever, and then, like you manipulate something within person. Again, within person manipulation, this is kind of a design thing, but it works best when, if you're really trying to make inferences, it works best when you can sort of intervene and have an impact, and then sort of when you take the gas, like right when you stop intervening, it you can go back to baseline. Like that's makes her stronger with in-person design. But anyway, yeah. Okay.
It's important.
Okay. It's a similar idea, right? So like it's this thing that's happened. So you've got this thing that's it's treatment or not, but it's within person variable, right?
For 7 days.
Yeah, exactly. So you can absolutely have within person treatment variables. Okay. So everybody good on, so you kind of get the fundamentals of like this idea of group mean centering and adding the aggregate back in. Yes, we're going to go. So right now I'm going to show you. So this was like the 50,000-foot view. We're all on the same page about conceptually what we're doing, I hope. So now I'm going to show you how to, and I don't think we have any missing data for this homework example yet. So I'm going to show you how to do the centering, how to add it into the equation. And then actually in my opinion, that's the easy part. The hardest part of group mean centering is always just thinking through the interpretations, right? So we're also going to talk about that. So we're going to do this example where we're going to take this NYS data and we're going to do like a grand mean centered example, and then we're going to do a group mean centered example. Let me just say one more thing before we move to that. Okay. We remember when we talked about contextual effects in class when we were talking about cluster, organizational models. Remember I said, and this is what you did for your homework. Remember I said, okay, well, if you group mean center a variable, you absolutely want to put the aggregate back in at level 2. But I said another way that you could kind of partition the variance, but it's going to be different partitioning of the variance, but you could grand mean center the level 1 variable and then put the aggregate back in at level 2. Do you remember that? And I said, if you group mean center the variable and you put the aggregate back in at level 2, then the contextual effect really is the difference between the within and the between coefficients. But who remembers what the contextual effect is when you grand mean center the variable and put the aggregate back in at level 2? Do you remember? What the big difference when we grand mean center is, when we group mean center, we've created these two variables that are orthogonal to each other. We've really taken this variable and we've created a within a level and a between level. And if you were to run the correlation between those two variables, the group mean centered variable and the aggregate, guaranteed it's going to be exactly 0. Do it, try it. It's really fun. So that correlation is going to be 0. Those two variables are uncorrelated. Not so if you take the grand mean centered variable and the aggregate of the variable, right? Because the grand mean centered variable still has the within variance and the between variance. It's still your like variable. It's got both sources of variance. And the aggregated variable only has between variance in it, right? So assuming that there is between variance in the variable that you're grand mean centering, which seems like a fair assumption, assuming there's between variance, then the correlation between the grand mean centered aggregated variable, or the aggregated variable, which is usually grand mean centered, but maybe doesn't have to be, that doesn't really matter for this, the aggregated variable and the grand mean centered level 1 variable, that correlation isn't going to be 0. So that's why when you put both of those variables in the model, you're really like you're still controlling for the one variable when you look at the other variable, right? So if I put in grand mean centered SES, let's say, is my predictor. I think this was an example we had before. If you put grand mean centered SES in the model, and then you put the aggregate SES, so mean SES in the model, the effective mean SES is really going to be the effective mean SES controlling for level 1 SES, or it's like the unique effect, sort of the effect of mean SES over and above. This is maybe an easier way to think of it. Over and above the level 1 effect of SES on the outcome variable. And that's why when you're looking at the contextual effect and you grand mean center a variable, the contextual effect really is just the coefficient for the level 2 effect. Because the coefficient for the level, because you are controlling for, because again, the contextual effect is the difference between the level 1 effect and the level 2 effect. But when you grand mean center the level 1 variable, you are controlling for it. And so the level 2 effect is the level 2 effect after controlling for what's going on at level 1. So it is the level 2 effect over and above what's going on at level 1. So remember how we talked about, in class, we said like that contextual effect right? So now you've got these two pieces that are independent. Not, let's say, I'm not going to give these any subscripts for now. I'm just going to call them gamma between and gamma, just to be easy. We're in our equations, right? So like we've got a gamma, well, and for the group, then for the aggregate, I've got the gamma for the between. So these would be like my parameter estimates, right? And if I want to get the contextual effect, it's the gamma between minus gamma within. And again, that's if I'm, this is what group means centering. Okay. Way. Second time around hearing about centering, centering is one of those things where you have to hear it about like 17 times.
I'm understanding it now. It's like the fourth, fifth time.
I was going to say, I remember when I was learning, I mean, and it's one of those away. I mean, seriously, I remember the first time I taught this class, which was, and I had been doing multi-level modeling close to a decade at that point. I had published a bunch of stuff on it. I had been I co-taught Dadic with Anna O'Connell, but she always did the set lecture. And I remember the first time I was going to teach this, I was like, I'm so scared. And it's like so silly because it's like one of the things you have to do like week 1 of, you know, like it's so fundamental to everything you're doing. Also so like, okay, so remember I said that, I was like, this is one of the, so grand mean centering. Okay, and I want to look at the contextual effect still. Right, so I've got the grand mean centered level 1 variable. Call this gamma within it. I'm going to call it gamma WB. Gamma within in between. How about that? Because, right, it's not really purely anymore like over here when I've partitioned out the variable by grouping set. Level 1, this is only level 2, right? But I've got a grand mean centered variable that I said I still have within and between variance in my grand mean centered variable. So this gamma is kind of like a gamma within and between, right? And then I'm going to add the aggregate back in at level 2. It's actually really going to be, I'll call it grand mean centered. So gamma grand mean centered, and this aggregate is really not going to be this over here as it was over here. What I'm going to get actually is between like the grand mean. What I'm going to get is the gamma between minus the gamma within centered is actually equal to gamma between minus grand mean centered. This thing, this gamma, I'm going to call it gamma aggregate. I don't want to confuse you, but minus, or not minus, sorry, gamma Okay, I'll just call it for this one. Maybe this won't. Gamma between minus gram mean center. Because literally, this is it. This coefficient is going to be the same as going gamma between minus gamma within. Is going to give you the gamma between, I want to call this thing. But this, again, by the way, this only works perfectly mathematically if the slope of the time varying covariate is not randomly varying, which in the homework it's not, by the way. But like this doesn't hold exactly and identically when the slope is allowed to randomly vary, but you'll get close. But the idea is that like really, it's really, right? I take the between minus the within, that is my contextual effect. Over here, my contextual effect is the level 2 effect, because when I grand mean centered, I have both the between and the within variance in the grand mean centered variable. So I am still controlling for this. Like, so this effect, this thing, gamma, whatever we want to call it, I'm calling this, right? Like, it really does give me the between minus the within because I'm controlling for it at level 1, because I'm controlling, so it's really like, what is the effect of this aggregate over and above whatever the within effect is? So it's like, how much more does the contextual effect, or less, because it could be negative, right? But how much does this contextual effect differ from what's already operating at level 1? Does that make sense? Yes. No, well, no, your grand mean, so you're taking the overall mean, like everybody's got their own value, let's say. Then you're taking the overall mean and subtracting it from their value. Oh, we're not literally adding back in the aggregate, like, I'm just saying like this, I'm just saying like over here, okay, what I'm trying to say, but not very well, is this aggregate looks the same. This is the same variable. This is the aggregate, like it's the level 2 variable. The thing that I created when I group mean center, it's the mean, the level 2 mean, right? It's the same either way. It's the same variable. So this is kind of, and this happens a lot actually. We're putting the same variable in the model, but the parameter estimate, we're only going to get one of those. The parameter estimate means something totally different. Over here, we're putting in the aggregate, which I don't mean as like the total, like across everybody. I mean like the person aggregate or the cluster aggregate. I put the aggregate in over here, but because I put in the group mean centered variable, this aggregate is it gets the chance to explain all of the between person variance, because there's no between person variance here. So I'm not controlling for anything here. I'm like when this, because they're at 2 different levels and they're completely uncorrelated with each other. Because remember what I said, the correlation here is 0. So if 2 variables are completely uncorrelated with each other, then you're not actually controlling, like you can put both variables in the model and you're not really like controlling for one of them. And actually then the amount that you can explain is going to be like an additive effect in that case. That almost never happens in multiple regression. You almost never get 2 variables that are orthogonal. But in this case, that's exactly what we've done, because we've created these 2 variables that are orthogonal. So this variable comes in and it's only got within person variance. So that's all it can explain. And so then this is the within person variance part. And then this variable comes in and it is the aggregate. It has no within person variance. So it can only explain between person variance. So it comes in and explains the between person variance. And we say the contextual effect should be how much over and above sort of like the within person effect or the within cluster effect, how much over and above that is the between person. So like if there's no contextual effect, then gamma B equals gamma W in the group mean centered case, right? They will be equal. So you could do a group mean centered thing, and if these 2 coefficients are equal, that means that there is no contextual effect. Yeah.
Grand mean centered. Just the contextual.
This grant, yes, exactly. This thing, this is just all of that. This is the true contextual effect. I do nothing to it. Because, and again, this is the same aggregate, and this is always a really interesting thing because, like, it's the same variable, the exact same variable. I'm putting it into the model. What's different is the level 1 variable. The level 1 variable is different, and what's different about this level 1 variable? I didn't strip out all of the between cluster variance. So now when I put in the level 1 variable, it is correlated with the aggregate. See what I'm saying? And because these two things are going to be positively correlated with each other, that's why I am controlling for this variable here. And that's why this variable is only going to be the, like, how much can this aggregate variable explain over and above what that grand mean center variable already could explain? Because they are correlated with each other, because it still has the within and between variance, and because they're still positive, because they're still correlated with each other, this is the effect of the aggregate over and above the effect of the grand mean centered variable, and that's what makes it the contextual effect. And you can always go back and forth between these, by the way, not one from the other. Yeah.
So for complete. Clean effect. Plus the contextual and that.
So like, yeah, so you've got the, yeah, this is the contextual effect, right? And this is, yeah, exactly. So you've got the, so you can just mathematically go back and forth, right? So you've got the between minus the within contextual. And so then the contextual is just going to be, right? So you could go the, you know, you've got these two things. If you wanted to get like the within would be like the contextual. Right? So the contextual effect is between minus the within. And here we have the contextual, like, and here we have the contextual effect, and we have the between and the within. So you can just go back and forth, right? We know this is the between, we know this is the within, we know the between minus the within is the contextual. And then this is going to be the same. Yeah. So.
Yeah, two-parter. One is just kind of a semantic question. Talk about adding back. Part of it confuses me because it's like,
Adding the variable back.
but yeah, like, I mean, to me, like, we're just adding it to level 2, but there's a sense that it was in it before, and we're just like, we took it
Oh,
out.
you mean like when I say back?
Yeah.
No, maybe I shouldn't say back.
Yeah, it's like we're just adding it.
We're adding it in. That's
Okay.
really technically much more accurate,
Okay,
right?
cool. Just want to make sure I'm not missing something there. It's
Yeah,
like,
yeah,
we took
yeah,
it
yeah,
out.
yeah.
And the other thing was when we were doing organizational models at level 2, you could,
Yes, you can only do grand mean center.
but with longitudinal or growth models, you've got more options. Centering is that?
I'm sorry.
I'm just saying at level 2, since level 2 is a different to the organizational
Yeah.
models, we have more centering options at level 2.
Not really more centering options. Like maybe you would think about them differently, but you don't really have more centering options.
You can still really only
You
grant.
can still only
You can, like I said, you could grand mean center. I said you could not center. You could center around some other meaningful variable, but those are still the same
But you
options.
can't group it.
right.
You can't group mean center.
Well, like, so in chapter 9, right, there goes so the, like, we can starting.
Oh yeah, centering at initial status.
Yeah, is that also something you can do?
Yeah, I mean, you can only center it at initial status at level 1.
Okay.
You could put in somebody's initial status as a level 2 variable,
Mhm.
but you could only center at initial status at level 1.
Okay.
Right? Like you can't, again, at the cluster level, you only have between cluster variance.
Right, and that's true at level 2, even when.
Yeah.
Because we're still looking.
Yeah.
Okay.
And just to like circle back in case I wasn't clear about this, right? So here we should get the, again, we don't have don't have randomly varying slopes, the effect that we get, like this between effect is going to look really different because we're going to have the between effect versus the contextual effect. Really, the within effect should look the same. Like this is a within effect here, and this is like the grand mean centered effect here. But these coefficients are going to be the same. It's just that like here now, this is the difference, right? Again, as long as you don't allow the slopes to vary. If you allow the slopes to vary, then they necessarily see this mathematical equivalence. But when you don't allow the slopes to vary, which is kind of interesting because what you're going to see is this variable is the same in these two models. Its coefficient means something completely different. This variable is the same across these two models. Its coefficient is going to be identical. It's going to be interpreted slightly differently across the two models. I mean, not too much, right? It's virtually identical. But again, we're thinking about the models differently. But it's kind of an interesting phenomenon because it's like and we see this in a couple of other places. Like we're changing the one variable, we're changing out one variable. It's not that coefficient that's going to be the one that changes. It's actually going to be the coefficient for the variable that is literally across the two models. But because I put in this grand mean centered variable versus the group mean centered variable, what I'm getting out is very different because now these two variables are correlated. So this is just the independent effect after controlling for this. Whereas over here, I've got like two completely separate effects. I've got the within effect and the between effect. And the contextual effect is just going to be the between minus the within. Yeah? It's going to make a lot more sense when we look at it, by the way. So we should, oh my gosh, it's 10 out of 10. Let's start and then break. I think it's too early for a break. Then they'll be really long.
Yeah.
Is this a question about this?
Yeah.
Okay.
So what if there is a correlation between as you said, there is a correlation between the level 2 aggregate. What if we create a variable there's an interaction of it, and there is a gamma, for example, gamma correlation, like
Well, then you've got to, I mean, so I was just using this tiny little piece and talking about this, but all of the same rules of like multiple regression or multi-level modeling are going to apply there, right? If we have another, like if I have another variable in there at level 2, like what I'm saying is the contextual effect is still going to be after controlling for that other level 2 variable, right? Oh, you mean an interaction between yeah, and you could have an interaction between the aggregate. So what would it mean if I have a time varying covariate at level 1, the aggregate in at level 2, and I don't just, when I keep saying put the aggregate in, right, it's not saying, but I say put the aggregate in at level 2, right? I'm always thinking of putting the aggregate in at level 2 as a predictor. Probably should have said that really explicitly. You could also put the aggregate in as a predictor of the slope, growth slope, but also put the aggregate in as a predictor of the time variance slope. But when I say you have to put the aggregate back in, like you have to put it in as a predictor of the intercepts, the randomly varying intercepts. Like that will do what you need it to do to get the contextual effect and to have the model run right. That doesn't mean you couldn't put it in as a predictor of the growth slopes or as a predictor of the time varying covariate slope. But let's think about what that means, because that's like kind of like a little tongue twister or brain teaser too. If I put in aggregate, I don't know, what's one of our time varying covariates? Let's say it's stress. Let's say this is stress. And this is like within person deviations from your own personal stress, right? And this is like the person stress. Okay? It's kind of hard to see it. Then give myself some more room. Okay, so let's just think about group. I mean, you could think about this for grand mean center too. It's a little bit muckier because we haven't done the partitioning as nice, but so let's say group mean center. So I've got within I've got my own, like, got group mean centered stress. So now this variable is just telling how much I deviate from my own personal stress level. Like, am I more, like, imagine it's daily stress, right? Am I more stressed today than I am usually? Like, am I more stressed than average? Am I less stressed than average, right? And it's person mean centered. So there are going to be some days I'm more stressed than average and some days I'm less stressed than average. Positive and negative numbers there. So how much my stress deviates from the overall average. And here, person mean stress is how stressed am I on average? Do I tend to be a more stressed out person or a less stressed out person? Okay. Now, cross level interaction. So now I've got stress.
Person, so that would be your 7 day. 7 time.
Yeah, it would be your average over
Your
the week.
average over the.
Yeah, and that's exactly right. So let's say you've got a 7-day study. This would be like the average over the week. Got a month-long study. This person's stress is like the average over the whole month, right? So now I've got this cross-level interaction between stress, like again, within occasions, and my person level stress. So what does that mean? The overall, yeah, the overall, so this is like my mean stress. My mean stress level. Over here, this is my daily fluctuations from my mean.
Something. Something.
Oh,
like
God.
Max minus min.
Well, I don't know if I do that. Probably not a bad idea. But you bring up a really interesting point. But the question was, could you put in the amount of variability that a person, I know Jennifer's gonna, dissertation is about, and she so wanted to talk about this in class. So could you?
So sorry.
We'll open up again. So yes, you could actually, because you could imagine that not only are people different in terms of their like means, right? Like people aren't just, but maybe some people vary more. So like maybe some people are like, it's not just about like, are they more or less stressful people, but maybe a quality of some people is that their moods change much more dramatically. Like you could sort of imagine like, there are certain types of mood disorders where it's like frequently cycling through like, mania and depression and that kind of thing. And so like, it's not, maybe if you looked at that person on average, they might actually look really great on average, like but because of these huge mood swings, right? It's the variance that's the problem. So you could absolutely, the way that people did this, sort of the original, like poor man's way of dealing with it isn't the max minus the min, but it's actually taking like the person's standard deviation or their variance, usually standard deviation or like a natural log of a variance or something. And putting that in the model. Again, it would be at level 2 because now it's a person level characteristic. But there's a whole set of models that Don Hedeker, who does a lot of work in like biostat, is one of the people who really kind of spearheaded these models. And they're called mixed effects location scale models. So everything that we've been talking about are mixed effects location models. We've been allowing for random effects on what's called the location side because we're allowing for like the level to we're allowing for the intercepts to randomly vary, right? But you could imagine a model, which we will not do this semester, but I at least want you to imagine it. Think of it, dream of it at night. You could imagine a model where not only
On a desert island.
nightmare, but imagine a model. Well, okay, but imagine a model. IJ, right? Goodbye. Times are time, I'll make it even more general. Times are time varying covariate, plus E sub Ti, right? Ti, here we go. So here, we're saying like the intercept could randomly vary across people. We're saying that the slope could randomly. But with the mixed effects location scale model, say what? Now, again, remember here, we're taking this across in person and across people. We're, in general, the variance of this equal to squared, right? We just get one sigma sample. But what if we think that what if we think that the variance isn't constant across people? Like, if we only get one variance, we're really saying that again, these are the assumptions that are baked into our models. We're really saying that within the variance, basically, maybe not the same, but like it's not like systematically different across people. What if we think the within person variance should also be allowed to vary across people? So the mixed effects location scale model actually allows that to happen by saying, okay, instead of just fitting one sigma squared, we're going to fit like an intercept. So scale is often what people like variances. That's what it is. Right. So when we talk about scale variance, really talking about variance in terms of variance and variance, basically variance variability. So here, what we're saying then is like, what if also built a model? So a model to predict level. What if we built a model that said you could have an intercept? So this is like the intercept would be like the overall amount of variance on average across the sample. And then we allowed for there to be slopes. Different things could predict why some people are more variable than others. So like, imagine that we're saying there's a lot more variability and stress across people, but maybe I think that variability might be predicted by gender. I might think it might be predicted by occupation. Although that's not mean stress. I'm talking about variability and stress, right? But maybe I think some jobs have more variable stress levels than others. Not just more stress, but more variable stress. And so I can put in predictors. And then finally, I can put in a random effect. That's really what makes mixed effect. That's the mixed effect part. Because you can do heterogeneous models really easy now for prediction of differences across, differences in the level one variance. But what the Hedger model does is says, not only can I use fixed effects to predict differences, but I could also put in a random effect for the random. So I'm saying people also randomly vary in terms of the variances, right? So really cool model. So you could do that. Or you could just like maybe, or you could put it at level 2.
Saying it was from biostats, so I can see how like rate and stuff like that. See it being useful for like daily.
It's super useful. And in fact, most of Hedeker's research is daily diary research. Yeah, so you should definitely, it's Don Hedeker, so you should look him up. And he does daily diary studies, and he's looking at, and a lot of it is like drug use, tobacco use, that kind of thing, and looking at how, anyway. So yeah, you can totally do that. But back to our question. Sorry, that was a little sideline, but tiny bit in. It's a super cool model, but as you can imagine, it gets a little. But that, right? Okay, here we go. Back here, I got my fluctuations from my mean. I'm assuming that I only have one variance across everybody there. So I got my daily fluctuations from my mean. So I'm fluctuating from my mean. And I've got person level stress predicted fluctuations, right? Like I've got this cross level interaction. So how do I interpret this? What does this really mean? Okay, it's saying like my overall stress level, right? My overall stress level moderates the effect of my daily deviations in stress on the outcome variable, whatever my outcome. Anxiety, depression.
Yeah, if you
whatever.
think about it as productivity, you might think that somebody who has a high level of stress all the time has developed mechanisms, like coping mechanisms and strategies, and they're able to be super productive no matter how stressful life is. But somebody who has a low level of stress doesn't have those strategies.
That's a great example. So yeah, exactly. So maybe somebody who's under a great deal of stress all the time So those deviations, those daily deviations in their stress level have less of an impact. Yeah, let's say productivity is their outcome. So let's say those daily deviations in their stress level have less of an impact on their productivity than somebody who generally has a pretty low level of stress. And so like, you know, again, so those deviations, so like when they are under high stress, that that high stress level has more of a negative impact on their productivity than it does for somebody who's just got a very high overall stress level, right? That's kind of the idea. So you can sort of imagine, you know, with any kind of personality or state trait character, imagine this is like this is in-person deviations, and this is kind of like the person's overall, I mean, meant to be a proxy for sort of it's almost like their overall trait or their overall, like what they're like overall, right? And so their overall characteristic could, you know, being higher or lower overall could absolutely moderate the effect of those within person deviations on the outcome variable. That's really what this is. So you can absolutely model that. Sometimes, you know, sometimes it makes sense. Like, again, it's all about your research question, right? In some cases, you might look at that and be like, that in my study, that does not make sense. Like with the variables I'm talking about, I can't think of a reason that I would want to look at that cross-level interaction. That's true of interactions in general, right? Like sometimes it's like, yeah, I can't think of a good reason to look at that. Doesn't make sense. And other times it's like, oh yeah, I totally need that. Like there are examples where absolutely you would want that in the model. Okay. Well, this with which the, oh yeah, the interaction coefficient. Well, sure, because anytime you have, remember, this is again, going back to the basics, anytime you have an interaction, then you really have to interpret the main effects in the context of the interaction. So yeah, absolutely. If you have an interaction between, like, if you have an interaction between the between the cluster mean variable and the the centered within context variable, right? Then the parameter coefficient for the main effect of this is held, right? Because what you're saying here is you're saying that the effect of within person stress level on the outcome, like this coefficient would be like aggregated at the coefficient for the by aggregated interaction, right? Before you have that, right, like you're just saying like this is the effect of within person deviations on the outcome, this is the effect of the aggregate on the outcome. As soon as you have this, saying this is the effect of within person deviations on the outcome, holding the aggregate at 0 at the overall mean, right? And this coefficient is going to tell you how much the aggregate changing is changing the effect of the within person on the outcome. And whether the sign is positive or negative is also going to be telling, like, again, in conjunction. That's telling you. Now, I always, like from regression, you should remember it. And from ANOVA too, right? As soon as you have interactions in the model, your main effects always have to be interpreted. Some people say you can't interpret your main effect. I don't like saying it that way. I like saying you cannot interpret your main effects without consideration of your interaction, right? Your main effects are no longer just pure simple main effects. They aren't just like, it's your main effect when you have moderation. And whenever you have moderation, it's like, that's telling you a when or under what condition. And so the main effect for CWC here is the effect of CWC when the aggregate is equal to 0. The main effect for the aggregate here is the main effect for the aggregate when the CWC is 0, right? So, and the effect of that CWC by aggregate interaction is telling you about how those two variables like how one of the variables moderates the other variable. And you can always think about it either way, like how the aggregate variable moderate, but I like it this way. In a cross level, to me, it makes more sense to talk about how the level 2 variable moderates the effect of the level 1 variable on the outcome. Yes. So when you have like, okay, so whenever you have, if you have a whole bunch of predictors, right, then always your coefficient for a predictor is always going to be after controlling for the other predictors, right, or holding those other predictors constant at 0. That's true. But yeah, now once you have the interaction, now you also have to think about it in the context of the interaction. But it is true that both things are happening simultaneously. So when you've got a big model, you've got a lot of moving pieces, right? So you got to be thinking about, you've got partial regret, we've got these partial regression coefficients, but we also have these interactions, which are actually these moderational effects that are saying that my partial, because a partial, without interactions, we're sort of saying, yeah, we've got these partial regression coefficients. But all of this stuff is additive, right? So in terms of like predicting something, I can just sort of add like all of these different pieces together. As soon as I have an interaction, it's like, no, well, I mean, again, I got to add the interaction piece in to get the predicted value, but I don't have additive effects anymore. I'm really saying that the effect of one of the variables is moderated by one of the other variables, so that the effect isn't just the same across the entire range of people or circumstances, but it varies as a function of that level 2 variable, right? And this is where actually, okay, now it will be time for a break. We should have taken a break, right? But this is where it's really like the interpretation of these coefficients is the, like, and I, in retrospect, probably gave you some mean things to interpret in a couple of these homeworks because there were a lot of interactions, but like they weren't crazy big models. They're kind of the kinds of models that you would fit. And like, yeah, it's the devil is in the interaction. I mean, not interaction. Well, that too, but that was a Freudian slip. But the devil is in like the interpretation, I feel like, of these models. And you should be able to think through the interpretations. Like, again, what would it mean if this coefficient were positive or negative? What does it mean to have this cross-level interaction be significant and positive or negative? Those things you should be able to think through before you ever run your model. And you should think them through. Like, you should definitely make sure that you're going to be able to make sense of the coefficients that you're putting in. Like, and honestly, I mean, that might sound really silly, but I think that's a kind of a good rule of thumb. Like, if you're putting together a model where you're not going to be able to interpret the coefficients, that's probably too complicated a model, right? That's like, we talk about parsimony being important, and we talk, we do all this model fit stuff with parsimony, but there's a level of, like, part of parsimony is if it's so complicated you can't make sense of it, like, well, nobody else can be able to make sense of it if you can't make sense of it and it's your own model. But like, if it's so complicated that you can't make sense of it, then like maybe it's too complicated. I always think of like ANOVAs, when you, and in a lot of ways, again, when we talk about interactions, it's very much like that. In ANOVA, you can fit a 6-way interaction, right? You could run a 6-way ANOVA and you could have a 6-way interaction. It's doable, it's runnable. Could you interpret that 6-way interaction? I mean, again, maybe under some circumstance, maybe your research project is exactly that. I'm not saying it can never be done. I'm just saying under most circumstances, I would say the answer is probably not, right? And so that should be your stopping point. If you get to a point where you're like, holy crap, I have no idea what this parameter is going to mean, then you shouldn't put it in your model, I mean, that sounds really silly and stupid, but it's actually, I think, wiser advice than it might seem on the surface. All right. Any other questions before? Now we'll take a quick break and then we'll come back. Oh, and during your break, make sure to pull up the NYS data file. If you're planning to, do along, make sure you pull up the NYS data file and the, whatever it's called, my R markdown file. The 22. It does, the only difference between NYS 2022 and NYS 2020, or no, just NYS, it doesn't have 2020. The only difference is in the 2022, I stripped out a bunch of the prior centered variables just so it would be a smaller data set. So it doesn't really matter. I think I had it as the NYS 2022, and then I realized I didn't load it up here as 2022, so I changed it back. But yeah, you can use either one. And we have all the code to create all of our centered variables. So use 2022 if you've got it. If you're using a desktop here and you don't see 2022, then just use NYS, but it really won't matter. Variables from scratch. Okay, so let's come back at 10:40. Okay, so here we go. Okay, so there's a lot, of course, this big packet has a lot of stuff. We're not going to go through every single thing in the packet because some of this is, I think we've already covered. Yes? Sure, absolutely. Okay. All right. So, okay, so this is incorporating time varying covariates. I already gave you the setup, right? I think we've talked pretty extensively about how to incorporate time varying covariates. I kind of want to make sure that we get to the part where we talk about the group mean and the grand mean centered. So let's see, actually, so you all have the packet. So take a look at, before we actually run anything, take a look at the packet. That's probably good. And let me make sure my subscripts are good. Before, it's always possible that I've missed subscripts too. I'm not going to say I haven't. Okay, so here we go. So page 3, if you look at, let's take a look at our models on page 3 of the packet. So you can see we've got our level 1 model, right? So we've got attitudes, and this is attitudes for person T, or sorry, person I at time T. So time T for person I, or right, is a function of, right? We've got an overall intercept, or, well, pi sub naught I, actually, we don't have the overall intercept yet. This is this intercept for person I, right? Pi sub naught I is the intercept for person I, plus pi sub 1 I is going to be the slope, and this is going to be the growth slope for person I, times, and you can see that's sub 1 I, right? Because all the pi's have i's, because they random, right? They can theoretically randomly vary by person, right? The T is going to come in for anything that can vary both across time and across people. So you see where it says age 11 sub TI? The age 11 sub TI, that's because, think about what our data set looks like. We have a column and it's called like age 11, and we've got, 5 rows for each person, remember, because we've got this long data set, and we've got, at each time point for each person, we have some value, right? So that's why it's, sub TI there, right? So, but the actual slope could vary across people, right? There's one slope per person. So that's why it's a sub I. Does that make sense? Okay. And then we've got pi 2 sub I. That's going to be the effect of the time varying covariate on the outcome, right? And it can vary across people. Remember I said doesn't vary across time in this particular example, right? And then, but the exposure to antisocial peers, again, we have a score for each person at each time point. So we've asked them 5 times from ages 11 to 15 about how, what their peer group is like. And so that's why that's got a sub TI, right? So the level 1 variables are varying across people and across time, right? But the level 1 coefficients are just varying across people. Now, the exception to that, of course, is the E sub TI, because the E sub TI is telling me about the difference between the persons, like, again, so you can sort of imagine each person's got some predicted score, right? And then what's the difference between like their predicted score and their actual score? This is the, or, you know, again, imagine the person's got this trajectory, right? They've got some sort of a growth slope, and the E sub TI is really capturing like, yeah, I've got this value or whatever, and then this is error that is, you know, within, right? It's within time point and within person. And then we're, again, remember, sigma squared is the variance of that E sub TI that I said before the break. We're sort of assuming we're pooling across time within people, and we're also pooling across people. So we're pooling it both across time and across people. And we're just sort of assuming that that we don't need to sort of differentially model that for each person. So that's the E sub TI. So far good on the subscripts? Okay, so then, oh, well, I can see a mistake right here. Because, right? Sorry, they shouldn't be J's. That's my bad. I totally cut and pasted, right? So anywhere you see J's in here, they should be I's. Because they're J's when we were doing the organizational. So don't let that throw you. I'm sorry, I apologize for that. So here, and it's weird too, because I got a J for the first pi, but then I changed the second and the third pi. So it should be pi sub naught I equals beta naught plus R sub I, right? So we have no J's. Get rid of your J's for longitudinal. We use J's not for longitudinal. But everywhere that it says J, just pretend it's an I, because it should be an I. And what I'm saying here is that I've got pi sub naught I, that's the randomly varying intercept. It varies across people, equals beta naught. Now we just get one beta naught estimate. That's my fixed effects, right? My fixed effects don't vary across people. So that's going to be my my intercept, right? Plus R sub naught J, which is going to be how much R sub naught I. Now I'm seeing J's. R sub naught I, which is going to be how much individual I varies from the overall, like how much does person I's intercept vary from the overall intercept? That's really what that R sub 0 I is. And the same thing is going to be true for the slope, right? We've got pi sub 1 I, and here I've got an I, so that's good. It should be an I. Pi sub 1 I is equal to beta sub 1, 0. So this is the overall growth slope estimate across everybody, plus R sub 1 I, right? Which is going to be how much does person I's slope vary from the overall slope, the overall intercept of the slope, right? Or the overall slope estimate. And then pi sub 2 I is going to be a function of beta sub 2 naught, which is going to be the overall slope for the effect of the time varying covariate on the outcome, right? So this is like across the sample, what is the effect of, in this case, exposure? What's the effect of exposure to antisocial peers on antisocial attitudes? And then the R sub 2I, should be an I, R sub 2I is how much does that exposure slope vary, how much does my exposure slope vary from the overall exposure slope estimate, right? And then I take my variances in the R sub 0 I, R sub 1 I, and R sub 2 I, and I get my tau matrix, right? Which, well, I made a tau matrix for this week, but I didn't make it. All this. Okay, oh, I see a eraser over here. Okay, so tau matrix. Now I've got tau 1 naught, tau 2 naught, tau 2 1, right? And so I've got, actually, if I fit, and this is an unstructured tau matrix, generally what we're unless I tell you otherwise, we're fitting unstructured tau matrices. So that's my unstructured, right? So these are going to be my variances for the intercept, right? The randomly varying intercept. Exposure slope here. Actually, how do we interpret all of these things? Let's actually take a step back and say, this is, let me say, remember, we're always controlling for all the, we're always controlling for what's in the model, right? So that's true for our parameter estimate as well as for our time varying covariate slopes and our time slope. So for example, in this model that we just went through, because we have the time varying covariate, the time slope is no longer the unconditional time slope. What is it? It's the effective time on the outcome variable. Yeah, holding exposure constant at, again, well, it depends on how we centered exposure, right? But holding exposure constant at the overall mean, or holding exposure constant at the person's mean. If we're person mean centering it, right, then we're really holding exposure constant within person, but we're not holding exposure constant across people, because like in this model, because we didn't actually put we didn't put exposure in at level 2 yet. This right now we just went through the grand mean centered time one with time varying covariate. So in the grand mean centered, then we are actually, then again, in grand mean centered, exposure has both a within and a between person component. So we are holding exposure constant at the mean across time and across people. So the intercept is going to be the predicted score at age 11 for somebody whose exposure is at the overall mean, both across time and across people. And that's important because it's not the overall mean for 11-year-olds. It's the overall mean across all the time points and across all people, right? Which again, okay, so it's going to be, what's the predicted value at age 11 for somebody whose exposure is at the overall mean? That's going to be our intercept value. Our time slope is going to be what's the yearly growth rate for somebody, assuming that their exposure stays at the overall, is at the overall mean. So what would I expect to see as a yearly growth slope for somebody, assuming that their exposure is at the overall mean? Which is not going to be the same as the unconditional time slope, right? Before I put exposure into the model, I'm going to get what's the yearly growth slope. But this is what's the yearly growth slope for somebody whose exposure is at the overall mean. So I'm really holding constant the person's level of exposure, right? And it's also for not only am I holding it constant, but also this really is the growth slope for somebody whose exposure is at the mean, at the overall mean on exposure. Yeah. Which subscript? Uh-huh. Oh, include the I, you mean?
Yeah.
Oh, yeah, that's a good question, actually. So yes, we do. So what we do, if it's not randomly varying, we would have pi sub 2I equals beta sub 2, 0, and then we just wouldn't put in the plus R sub 2I. Because, so basically, so the way we're sort of setting it up is at level 1, we're saying yeah, each person could conceive of, that's why sometimes I'm kind of careful about the language, each person could have their own randomly varying slope, right, for the time for exposure, but we really don't know from the level 1 model alone if that's the case until we look at our level 2 equations. And when we look at our level 2 equation and we see that we're allowing for that pi sub 2I to be a function not just of the fixed effect, but also of the random effect, then we know that, yeah, in fact, people, then we are allowing for that variability, which means we're allowing people to have their own slopes, right? But if we took the R sub 2I out of there, then we wouldn't change the subscripts for the level 1 model at all. We'd still leave in the sub i's. But by not having the R sub 2I in there, that would tell us that actually we're not allowing for variance across people. So that's a really good point though, right? And I think that it can be kind of somewhat confusing. Sure. Okay. So, was there anything else? Oh, I was talking about making sure that you're very clear that we are controlling for, right, the other things in the model. So now for the exposure slope, this is the effect of exposure on antisocial peers. And we don't have an interaction between time and the time-varying covariate. So here, and remember what I said, we're making the assumption, really, because we don't have an interaction between time and the time-varying covariate, we're making the assumption that the effect of the time-varying covariate is constant. It can change across people, but it's constant across time. So here I don't have to say the effect of the time-varying covariate controlling for time. Like, because what we're really saying in this model is that the effect of the time-varying covariate on the outcome is basically going to be like, it's going to come in and it's going to sort of change the value, like almost like change the predicted value over and above what we had for like time and the intercept combined. So I don't have to say that. I can just say this is the effect of the time-varying covariate on the outcome, right? And it's, you know, it's grand mean, here it's grand mean centered. So, but that does mean, right, that when I come over, again, the time slope is holding the value of the time-varying covariate constant at the overall mean, both across time and across people. So the time slope is a conditional time slope now. It's no longer the unconditional time slope. It's a conditional time slope, and it's conditional on somebody having, like, you know, it's basically like, this is the time slope I would expect if somebody were at the overall average on exposure across all 5 time points. So like, think of it as that hypothetical person. I got a hypothetical person. They're at the overall mean on exposure from ages 11 to 15. So their exposure never changes, and it's just at the overall mean. This is what I would expect their growth slope to look like. And that's not the same thing as what the unconditional growth slope was, because the unconditional growth slope wasn't conditioned on exposure. So exposure was also changing. So it could look very different. So then when we come to our taus, right, we also have to, now this is a conditional tau matrix too. It's not going to be the same as it would have been. You know, you're not going to get the same covariance, let's just say. Let's think of this covariance. Now we've got, this is the variance in the intercept, right? Again, holding exposure constant at the overall mean. This is the variance in the growth slopes, holding exposure constant at the overall mean. And then because we're holding exposure constant at the overall mean for both of these, this is really the covariance between the growth slope and the intercept, or the randomly varying intercepts and randomly varying. Again, holding exposure constant at. So it's really conditional covariance. It's no longer the unconditional covariance. But this is an important point. Like, and if you look at the parameter estimates that you get across these models, you'll see changing, and that's why, because we're actually conditioning on things, conditioning on anything. So this is like a conditional covariance between the slope and the randomly varying slopes and intercepts, controlling for or holding constant exposure at the overall, again, at the overall mean, because that's the way I centered it. What about these two guys? I ask you to interpret all the elements of the tau matrix for homework this week, right? So you're in half now, right? So covariance between, or we can think of correlation between randomly varying intercepts and the exposure slope, right? So the covariance between the randomly varying intercepts and the exposure slope. Again, has to be interpreted then in the context of, you know, what the direction of the, like, what is the direction of the exposure slope, right? And what is the direction of that covariance? Remember, we talked about that a lot last week. We talked about, yeah.
For the homework, do you want to go into that? Or can we just say that one sentence? Or do you want us to?
Oh, I totally want you to contextualize it. So like, if the slope is positive and the covariance is positive, what does that mean? Yeah. For sure. Yeah. Well, yeah, the correlation is just the standardized covariance. In the output, actually, it gives you the correlations. It doesn't actually give you the covariances. It gives you the variances and the standard deviations for the diagonal elements. But unless you ask for like the data frame, that sometimes you'll see I ask for like the frame, then you can actually get the covariances. But if you just do the summary thing or the compare function, like most of the like regular stuff that you might do, it's going to give you the variances and the standard deviations for these guys. But then it only gives you the correlations here. You could always back transform, by the way, because right? You know that the variance basically covariance of x and y just divided by the square root of the variance x. Y is actually the correlation between x and y. This is like from stat 1, right? You all remember. Maybe you don't remember this, but it's a good piece to remember. So like, I'm not going to make you do this, by the way, but like you could theoretically correlation, and because you have the variances, you could really easily what the covariance is. But I mean, if you really want the covariance, do that. You could also just ask for the covariance as a data frame, and when you ask for it, is it like, and I have that code in parentheses, right? And if you save it out as a data frame, it will actually give you a column that are the standard deviations and the correlations, and it'll give you a column that are the variance. It's probably the easier way to get it, but anyway. So, but weirdly, and I think this is weird far personally, like what you're going to get are unstable. Well, I guess you do get the standard. You get the, you get variances and the standard deviations here, but you.
And they're not labeled, so it's always confusing.
And they're not labeled. They're just kind of tacked onto the side there. It is kind of confusing, but that's what they are.
That took me so long when I was learning.
Yeah, those are and they are correlations. Yes, Claudia. Sure. So that is the correlation. So it's the relationship between the intercept and the exposure slope. So let's do an example. I just said you had to do that for homework. So let me like contextualize it the way that you would have to do it for homework. So like, let's say that the exposure slope is positive, which means, does that make sense? By the way, let me think about this. The more, it does make sense, right? The more exposed you are to antisocial peers, the more antisocial you are likely to be. So it makes sense that the exposure slope would be positive. I think it is positive. Okay, so let's say the exposure slope is positive, and so that means, so we just said what that means. And then let's say that now we need to think about what's the sign of the correlation. So let's say the correlation is positive, right? What would that mean? Okay, well, if the correlation is positive, that means people with higher intercepts or more positive intercepts also have more positive exposure slopes, but the exposure slope was already positive. So that means that people who start out higher in terms of antisocial attitudes, the effect of exposure on antisocial attitudes tends to be more positive. It's a more steep slope. So like exposure has more of an effect, right? Again, not causal, but exposure is more related to antisocial attitudes, or it has more of an effect on antisocial attitudes for those who have higher scores at age 11, which is where the intercept is. Does that make sense? Yeah, no, I was going to do that. So then finally we got tau 2-1, which is, now that's the relationship between my growth slope and my exposure slope, right? So so again, I got to ask myself, and this is why like there isn't like, you really have to like, there isn't any total crib sheet for some of this stuff, because you always really have to contextualize it. Like, I mean, there's a general rule, but then you really have to think it through. So let's say my growth slope is going to be positive, right? Because that makes sense. Kids are getting more antisocial from ages 11 to 15. And my exposure slope is positive as well, meaning that, we already said that, but meaning that, the more exposure you have to antisocial peers, the more antisocial you are, right? And so now let's say that it's a positive covariance there, which would mean again, it's not it's not it's not exposure, it's the exposure slope. So the more exposure affects, like the relationship between exposure and the outcome is more positive, right? When the growth slope is more positive. So basically, kids who are growing higher in terms of their antisocial attitudes tend to also, exposure also for those kids tends to have more of an impact on antisocial attitudes. So, and this is where I think Tau 2-1 is the one where people are most likely to slip up and make the mistake of saying kids with higher exposure have higher growth. Like that feels good, right? But that's not what this is saying. It's saying kids with higher growth slopes also tend to have higher exposure slopes. And the exposure slope is, again, the effect of exposure on antisocial attitudes. So it's really saying like kids for whom exposure makes more of an impact on antisocial, like kids who, when they're exposed to antisocial peers, they are more susceptible, right? That's the exposure slope I like to think of as like a susceptibility slope. That like kids who are more susceptible to the effect of hanging out with an antisocial peer group are growing faster in terms of their antisocial attitudes, which actually, when you say it that way, may make a lot of conceptual sense. Does that make sense? And that's kind of, I know it's hard, but that's the kind of thinking that I want you to do for the homework in terms of like just thinking through, again, and I don't care for this homework, so let me say it aloud. I don't care, you don't have to test the statistical significance for the TAUs for this homework that's due tomorrow. That is not necessary. I don't ask for it. You don't need to do it. Don't do it. If you already did it, that's fine. But if you didn't already do it, don't do it. And I want you, what I wanted you to do, like, was think through the interpretations of these components of the Tau matrix. And I deliberately didn't want you to test the statistical significance because I didn't want you to be like, well, they're not statistically significant, so I don't have to interpret them, because I wanted you to interpret them. So I was like a sneaky roundabout way. It was like, don't test it, just interpret them. And then like, right? Yes. Because I want you to just have the practice thinking this through. Yeah. Earlier in the homework with this, I think it's in the unconditional model slope intercept. Yes. So for that one, I want you to do it. But when you get to this part with the time varying covariates, I'm not asking you to do any testing. Yeah, for that one you are testing, right? Yeah. For that one, yes. But not later on when I just ask you, like with this Tau matrix that's like got 6 elements in it. You don't need to test any of them for statistical significance, but I do want you to think through and try, like, think through on your own, like, what do these things? I just think it's really good. Like think of this as like your homeworks are like your workouts. You're strengthening your multi-level muscles, right? You are like 6 packs, like multi-level 6 packs by the end of this class.
We're doing a 6-level model.
No. Boy, I'll tell you, and you think this stuff is tough? Just like 4-level model. I've never done anything more than a 4-level model. I've done 4-level models, and I've had to write 4-level models into grant proposals. And like just making sure you don't have a typo on the subscripts alone is like, Anyway. All right. But yes, you're gonna be ripped. In a good way. All right. So not ripped off. No, this is going to be great. Okay, so now let's say my group mean centered model. If you look down, other than, did I mess up? Do I have J's again? I have J's again. Make all your J's I's. But like, if you look at the group mean centered model, the actual equations, they don't look any different other than the fact that you're just saying, I've got the group mean centered level 1 variable instead of, well, actually, that's not true. They do look different here because I've also added in the mean of exposure. But like, if I didn't have the mean of exposure in, like the difference in centering, right? When I like substitute a centered variable for a different centered variable, like I'm just substituting it into the model. It doesn't really look that different. The parameters are going to be interpreted differently. Now here though, I have put mean exposure in at level 2 because I've said to you, it's really generally a big mistake to use a group mean centered variable without putting the mean of exposure back in at level 2. So let's think about what this means then. So we've got exposure, right? But now my exposure variable, the level 1 exposure variable, is no longer like the deviation of my exposure. Like here I am at this time point, right? And what's my deviation from the overall mean across time and across people? Because I've group mean centered exposure at level 1, right? That level 1 group mean centered exposure variable is just like the deviation of the student's exposure from their own mean, their own personal mean. So like, how much does my deviation from my own personal mean, right? How much does that affect antisocial attitudes? And then again, if I don't put in the person mean for exposure at level 2, then I've lost any of the between person information on how, like you would expect, some kids probably hang, again, across time, there's going to be some between person variability in terms of like the sort of the peer group that they're hanging out with. So some kids are probably generally hanging out with a rougher peer group than other kids. And that mean exposure is capturing the sort of like, that's the person average in exposure. So some kids are more in general, right? More hanging out with a rougher peer group than other kids. Now I put in the effective exposure, the effective mean exposure as a predictor of the randomly varying intercept. So that's saying like the person means, right? Like the higher a person's mean, well, let's say it's positive. So like the higher a person's mean is in terms of exposure to antisocial peers, the higher their predicted antisocial attitude score would be at age 11. That's really what mean exposure on the intercept would mean, right? And mean exposure on the slope would be like the higher a person's antisocial attitudes, the higher a person's exposure is, the higher a person's peer exposure is, again, let's say it's positive, the steeper their growth slope would be. This is a level 2 variable now. So now it is really it's mean exposure moderating the growth slope. So it's like one variable across time. So it'd be like kids who have higher exposure scores, they grow faster than kids who have lower exposure scores, potentially, right? That's really the mean exposure on the growth. So mean exposure moderates the growth slope. So the higher mean exposure is, again, if it's positive, the higher mean exposure is, the higher growth would be for, right? So kids who hang out with a rougher crowd grow faster in terms of their antisocial attitudes. That's what that would be saying. And then finally, we've got this cross-level interaction that we were talking about before the break, right? So we've got the effective mean exposure on the effect of like person-centered exposure on the outcome variable. So this would be like, and I don't remember if it's positive or negative, right? But let's say it's positive and let's say the exposure, the within person exposure slope is positive, and let's say the mean exposure slope is positive. That would be saying that people who hang out, like the higher your overall exposure is, your person level overall exposure is, the more of an impact hanging out with antisocial peers has on your antisocial attitudes. Well, maybe you might think it might be negative, like because you're hanging out with them. So maybe because you're overall hanging out with them, maybe it would be that there's less of an effect of peer exposure on antisocial attitudes. That would be like a negative. That would be a negative slope there. And we'll know in a minute, right? Yes.
Both of these equations. I'm looking at beta 20 times expo, right?
Mm-hmm. Oh, sorry. Beta 20 should be times expo in the combined model above. So that's a typo. There should, yes, the first combined model should be beta. Yeah, it's really. Can you send me an email about that so I can, any of these typos? Yeah, it should be beta 20. Yes, totally. It should be beta 20 times expo, right? They're always getting multiplied. So that's my bad. That's just a typo. What did I, let's see. Yeah, it should be beta 21 mean expo times expo. Yes, beta 21 mean expo times expo plus blah, 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 plus blah, 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 blah. Yeah, that's good. It's really hard because when I'm doing these, I'm typing them in like LaTeX and I can't really. Yeah, that's the interaction. So it should be in there. Yeah, so that's a big typo. So send me a note. I'm sorry about that. Yeah. The first typo is like the beta 2 not for exposure on the first model. It should be beta. If you look at the combined model, so the multi-level models are fine. There are just a couple missing things in the combined. So the combined model in the top should be beta 2 not times exposure. And in the second model, you should have mean expo, it's beta 2 1. And again, anytime you like, you should just think to yourself, like, it's a 2 1, it's gonna be a cross-level interaction. Like as soon as you see the 2 1, you should be seeing two coefficients there, right? A 2 not, no, but a 2 1, yes. So beta 2 1 is gonna be beta 2 1 times mean exposure times the within cluster centered exposure. So it should be beta 2 1 times mean exposure times exposure. Absolutely. Big typo. I apologize. And the same thing with level 1 with, hold on. Beta 1 1. Did I do the same thing? Yes. Sorry. Beta 1 1 times mean exposure times, and in that case, it should be beta 1 1 times mean exposure times age, right? Because, and that again, it's telling you age times mean exposure. Time slope times mean exposure, and it should be the mean exposure slope times the exposure slope. So in both of those cases, it should be beta 1 1 times mean exposure times time, beta 2 1 times mean exposure times exposure. So both of those should have multiplicative terms. So I apologize. Okay, I'm going to stop making these because I'm obviously not doing a very good job at it. Yeah, the within group should always have TI. Yes. The mean exposure won't have a T. Right? The C? Where it says mean, well, I'm looking at the group mean centered one. So the mean exposure should have an I. And the exposure sub TI, I don't think I made a, oh yeah, I see what you're saying. In the combined model, expo is missing the NH. Yeah, okay. So yes, I apologize profusely. I'm missing all kinds of subscripts there. That just means it's centered. Yeah. Okay. So cross those out and start from scratch. You can do a better job at this point writing equations than I can, clearly. So I apologize. Yes. I did not. I hate when people say that. I absolutely didn't. Maybe after the 7th typo. Yeah, right. I think that becomes a little bit. So I apologize. It's the ADHD kicking in. I'll blame that. But no, and it's also the LaTeX. And of course, I don't see the stuff until I render it, right? And that's usually I start going through stuff, but I never have enough time. I feel like I never have enough time to completely proofread these things because I can't really see those equations until I've rendered them, but I should, I guess, look at them in visual. So I will take Marcus's advice and go to visual mode so I can see them better. But anyway, yes. The request. Oh God, help us. I don't know at this point in the semester if I'm going to do any special requests, but go ahead. I mean, I think that a lot of that is actually in here. I really think it is. And I think at this point, I am going to say, I'm not making anything else. I'm sorry. I just like, this is all I can, it's in here. If there's something specific you want to put on the discussion board that you feel like isn't in here that I can like respond to quickly, I can do that. But like, I feel like there's a lot. I mean, there's a lot here. I can't even begin to tell you how much time it has taken to create these full. I don't want you to feel pity for me. Maybe I do want you to feel a little pity for me, because I cannot tell you how much time it takes to create these things for you. And I feel like I've got everything you need in here. So maybe I'm wrong occasionally. And if I'm wrong, and I'm certainly wrong about the subscript, so I apologize again about that. But like, if you feel like there isn't something in here, like, then let me know. But like, I think as we go through this, and again, we're running out of time, which is part of the problem. I think you will see that like, I do write interpretations about like what these things mean. It really is in there. Okay, so moving along. I think if I'm wrong, let me know. But I think we've got a lot of this in here. Okay, so I'm going to skip along though, because I do want to make sure that we get through the part where we're actually group mean centering. So let's see, where do we want to go? I don't want to look at the unconditional model. I'm not going to look at the plausible values because I feel like we've done all of that before. I'm not going to look at the testing the covariance between the slope and the intercept because we've done all of that before. And then let's go to page 9, including exposure as a time varying covariant. Okay, so the first thing, and this is something you do have to do for your homework. So the first thing I ask is like, what is the interclass correlation of the exposure variable? So page 9, and I'm going to scroll down. Page 9, top of page 9, where it says, well, almost top of page 9. Now I got to find it here. Predicted values, blah, blah, blah. Yeah, here we go. NYS linear growth model. Uh-oh. You know what? I can't totally skip because I probably haven't done some of the stuff I need to do up here. So hold on. Let me load the data because we haven't really run anything yet, have we?
No.
Okay. So I do need to load the data and I do need to create my variables. Okay. So I think I should be good there. So now I should be able to skip down to where I was. Any left? I think I did library already, right? Yeah. Okay. So there we go. So we got our exposure variable. And remember I was saying before the break, we might want to know what's the interclass correlation coefficient for the exposure variable. It's 0.49. So what does that tell you? About half of the variance is between people, right? 49% of the variance is between people. 51% of the variance in exposure is within people. So I think that's kind of interesting. So it's about 50-50. So like you can imagine then if you're going to add exposure grand mean centered into your model, right? For sure, like about half of the variance in exposure is between people and about half is within people. So for sure you've got sort of both things going. Now, okay, so should we grand mean or group mean center? I don't know. Oh, well, let's create our variables here. Ready? Got mean exposure. So grand mean centering, here we go. Here's my group mean centering. So I've got my NYS data set here. I'm grouping by ID, right? And then I'm creating, I mean just means the individual's mean exposure is equal to mean exposure, right? So this is going to be the person mean exposure is going to be I mean exposure. And then exposure CWC I always use as centered within context. So that's like level, that's group mean centered is equal to exposure minus I mean exposure. So you can see that that is exactly how I'm group mean centering it. Again, I don't have any missing data. And then I just run the mean here, which is a good idea, right? And you can see the mean is pretty close to 0. And then now I'm going to grand mean center I mean exposure, which is the person mean of the exposure variable. And nobody has actually asked this, but like a reasonable question might be, when I grand mean center an aggregated variable like this, should I be using the overall mean or should I be using the mean of the means? And luckily, a lot of times it doesn't matter. Again, if in a balanced design, it won't matter at all. But if you think about it, if you use the mean, right, let's go back to schools for a minute, because like in longitudinal, it's generally not going to matter because we're going to have about the same number of time points, or maybe we have a little bit of deviation where somebody missed a time point here or there, but overall it's going to be like really close. And in these examples here, it is going to be spot on. So it's not going to matter. But if you think about it, if you use like, well, again, and it depends on whether you use the weighted mean of means or if you just use the mean of means, right? So, or the overall mean. If you just take the overall mean across everybody, or if you use sort of like the mean of means across everybody, then actually you probably get the same thing. But if you literally only counted like each school's mean once, right? So if I said like, I've got 1,000 schools in my sample and I'm going to count each school's mean once and create the mean of those 1,000 schools, that wouldn't be the same thing as computing the mean of like every person across those 1,000 schools if you have different sample sizes within school. Do you see what I'm saying? Which, by the way, I don't, it's interesting. I don't ever see anybody talk about this. I tend to use the overall, well, certainly for longitudinal, we're going to use the overall mean, and it's really not going to matter. So I would tend to use the overall mean because I look at that as the weighted mean of means. So that seems good to me. But again, you want to sort of be thinking about that. Okay, so I digress. So here we go. I ran this. I think I ran this. I already ran. Okay, so I add the exposure slope, grand mean centered. Uh-oh. I didn't grand mean. I didn't. Oh, where's my grand mean centering code? Oh, here it is. Got to run this code. Okay, my bad. Okay, now I can come back here and run my grand mean centered model. Okay, here we go. So grand mean centered model. So let's take a look at this code first too. Pull it up here. Okay, so this is pretty easy, right? Oh, what page am I on, by the way? Here we go. Exposure slope, grand mean centered. So here we go. If we look at this code, we've got, okay, fine, attitudes. Again, I put to 11 plus exposure grand mean centered. Okay? And here, in this model, we're assuming that the exposure slope is randomly varying across people. So we've got the intercept randomly varying across people. The age 11 slope is randomly varying across people. And the grand mean centered exposure slope is randomly varying across people. And that's it. Okay. So it's a pretty easy model. And if I want to see a full summary, here's our summary. Okay, so here's our and we've got our interpretations, right? So so again, if you look here, I say if the exposure slope varies across people, it means that the effective exposure on antisocial attitudes varies across people. So think about it as a susceptibility parameter, that some people are more susceptible to influences of antisocial peers than other people are. So that is our susceptibility parameter, right? And then the interpretation of the model we have here. So we've got our beta not is the predicted attitudes for an 11-year-old whose exposure slope is at the overall average. Beta 1 not again is holding exposure constant at the overall mean. We see expected attitudes are increasing by 4.68 points per year. And regardless of whatever age they are, a 1 unit increase in exposure predicts a 0.35 unit increase in antisocial attitudes. So, okay, what do I, blah, blah. Okay, so, and we could test, again, we could do a bunch of model fit tests. I'm not going to do a lot of the model fit tests right now because I want to make sure that we get to the group mean centered stuff. But I don't think people are okay on the model. You tell me, are you all okay on the model fit stuff at this point? Mostly? Yeah, okay. So that's bad. I wonder why that would be. Yeah? Oh.
Thought it should be the same.
I think you probably, yeah, that's, I mean, there's, I would guess that that might, I mean, again, I didn't write this. I would, if you need. Some people. Oh. And then would get those converted. Someone stopped, like, undid it, or like rebrand and they did. So that's continuous? And it was. I mean, it should, but it shouldn't. But if it does, then I would put the order, I would put it in the same order as you put in the fixed effects. What I was gonna say, you should put it, if you find that you're having troubles, I would put it in the same order in which you put in the fixed effects. And I mean,
That both are fixed and random effects are in the same.
yeah, exactly. So your fixed effects part of the equation and your random effects part of the equation are in the same order. Because I could imagine, I mean, it's interesting because R is sort of agnostic about a lot of things about order, but I could imagine that there might be a scenario in which, like, if you vary the order. But the other thing to make sure that you do, where I think sometimes people are mistakenly grabbing a different version of a variable for the fixed and random effects, and that will also cause you major problems, right? So you need to make sure that A, you're using the same variable for the fixed effects and the random effects. So if you have, even if their variables are identical, like even if you have it like the same grand mean centered variable two different ways, you can really end up with problems if you grab the same variable, like if you grab a different variable and put it in. Especially because remember the whole, like, when you put the star, it's building out the main effects, right? So what I saw some people have a problem with is, like, let's say you put in something CWC in as a main effect, and then you put it in an interaction, and you use a variable that is like you don't actually use the same variable, but you use a variable that is literally identical. That's going to be a problem because if you do what I did and you have the same variable in as a main effect and an interaction, that's fine because it's the same variable. So you can put it in or not put it in. But if you have a slightly different variable that you put in as the main effect as the interaction, because it doesn't see the variable in as a main effect, it tries to build it out as a main effect again. And so that causes major, and I definitely have seen that on some people's stuff. So that causes major problems because it's taking that and it's building it out, but you already thought you put it in. So in some sense, it's safer to just use the star term and not put the thing in as a main effect if you're not sure, right? And again, you got to make sure you use the same variable for the random effects as the fixed effects. So yeah, all of that. If you put a slightly different variable in for the random effects as the fixed effects, that will also cause problems. And again, when we're creating all of these variables, it's like really easy to just inadvertently grab something that you think is the right thing. So anyway, but it's a little buggy too. I mean, not buggy, but okay. No. So I want to get to the group mean centered. So let's get to our group mean centered thing, which is, now I'm feeling really bad because I'm like scrolling through here going, do I have all the interpretations of the tiles? If I don't, I'll make you a page. But I thought they were in here, so if they're not, I will add to it. And sure. But okay, so let's get to our that's predicted values. Oh wait, hold on. Did I miss my group mean centered model? Group mean centered model? Yeah, here we go. Oh, I see a typo. Okay, so here we go. We've got the model for group mean centered exposure slope with grand mean centered exposure added in at level 2.
What page?
I don't know. I have to get to my page here. Page 10? 13.
Sorry, that was grand, yeah.
Yeah, so, okay, so on page 13, at the top of page 13, we've got a group mean centered exposure slope and mean exposure, gram mean centered added back in at level 2. So now this is where we really got to sit down and think about some stuff, because we've got this group mean, it's going to be a lot more complicated to interpret our parameters, okay? So first thing that I note here is this model has 2 more parameters than the grand mean centered model, but they're not nested. Why aren't they nested? Why are the group mean centered model with the aggregate added back in at level 2 and the grand mean centered model, why are they not nested? Yeah, because the level 1 variable is different, right? Because in the grand mean centered, I had grand mean centered exposure. And then to get to the group mean centered model, I had to take out exposure. I had to put in group mean exposure. And then I put in the aggregate, right? And so 2 models are nested when one model, like when you can get from one model to another model, either by adding stuff or by deleting stuff, but not both. If I have to delete one thing, like if I'm deleting something and then adding something else, then those models are not going to be nested. So the group mean centered and the grand mean centered models aren't going to be like the grand mean centered model and the group mean centered models are not going to be nested, right? But that doesn't mean I couldn't compare the fit. I can't do a likelihood ratio test to compare the fit. Okay, so that's the first thing I wanted to point out. And then again, now my random effect for exposure, if you think about it, is really capturing whether like person changes or deviations in exposure. So whether the effect of these within person changes on the outcome variable, whether that differs across people, right? So it's all about within person change. So like perhaps that like within person changes in exposure have a larger impact on people's antisocial attitudes for people when like mean exposure is lower or when mean exposure is higher, right? So we're really saying like the effect of within person changes in exposure on, and I said within person changes in exposure, but it should say within person changes in exposure on antisocial attitudes. That's implied. They depend on a person's mean exposure level. That, like, I think personally is a little bit of like a brain twister. I don't know, maybe it's totally clear to you, but I always have to kind of sit with that for a minute and be like, okay, like I got it right. Okay, but again, we talked about it before, but I think, okay. So what does this look like? We've got attitudes, we've got our growth slope, we've got our within person exposure slope, we've got our between person, like we've got our mean exposure effect on the intercept, and then we've got this cross level interaction here between exposure and mean exposure. So if you look at this model right now, what cross level interaction is not in here? The way this model is written right on the board, right? Yeah, there's in this model, the way this model is written, right? We don't have a cross-level interaction between mean exposure and age. It's not in this model, but we do have the cross-level interaction between mean exposure and the exposure slope, right? Oh, I didn't say anything. Okay, here we go. Okay, so let's see if we can, let me pull this up. Let's see if we can interpret this. To be, you have it on your paper too, right? Let me just make sure we've got the fixed effects. .84. Yeah, this is it. Okay, so here it is. So here are our, oh, where'd they go? Pull them up. Can't scroll them up that well. Well, maybe it's easier to look on your paper. Oh, yeah. So take a look on the page that we have. So we've got the intercept 22.84. I think that's, well, no, you tell me. You guys tell me. What would you say about the intercept? And again, remember, we've group mean centered exposure. So how do we, and we've got the mean of exposure added back in at level 2. So what are you going to say about the intercept? How are you going to interpret the intercept? Do you want to take a stab at it? This is on the, yeah, well, it's unfortunately the bottom of page 13 is the intercept and everything else is at the top of page 14. So sorry about that. But the very bottom of page 13, you've got 22.84. That's the fixed effect for the intercept. And again, in this model, we've got exposure as a time varying covariate. We've got the mean of exposure added back in at level 2 as a predictor of the randomly varying intercepts and as a predictor of the exposure slope, right? And we've got time, obviously, it's a growth model. So the intercept is what? It's the predicted value when, and this is the first thing you should think to yourself. The intercept is the predicted value when everything in the model is 0. Okay, when is everything in the model 0 then? Well, no, because we centered age at 11. Okay, so it's at age 11, but we got other stuff. We've also got EPSY CWC, right? So EPSY group mean centered is going to be when they are what? At their own personal average, right? And which is not necessarily going to be their, again, like not necessarily what they're predicted, like what it would be at age 11. It's like what they are when they're at their own average. So, okay, so it's the predicted value at age 11 when they're at their own personal average, right? What else have we got in there? Say that again. We've got mean exposure in there, right? So we're controlling for mean exposure. So when is mean exposure 0? I grand mean centered mean exposure, right? So when is mean exposure 0? When a person like if the person's exposure is at the overall average, right? So this intercept is really like, this is the predicted value at age 11 for a kid who's at their own personal mean for exposure and whose personal mean on exposure is at the overall average. Yeah? Does that make sense? Again, that's why I say it's like a little bit of a brain teaser, but I think it makes, you can make sense of it. Okay. How about the age 11 slope, which is, let's call it 5. So it's 5.005, but we'll just call it 5. So that's the yearly growth rate. The yearly, I mean, it's because time goes up by 1 point per year. So it's the yearly growth rate for, or like after controlling for, or holding constant at something, something, something. I can't just say it's the average yearly growth rate anymore, right? It's the average yearly growth rate. So it's the average yearly growth rate for, yeah, again, sort of assuming the kid is within, they're at their own personal mean, and then their own personal mean is at the overall mean, right? And so then that's the average yearly growth rate under those circumstances. How about the effect, the EPSY CWC coefficient? That's the 0.268 or 0.27. Let's call it 0.27. So what is that? The effect is definitely gonna be in there somewhere. So good start. Yay. What? The effect, okay, what kind of effective exposure? within person, right? And that's important because this is group mean centered now. So it's like the within person effective exposure on antisocial attitudes. But I can't stop there. Unfortunately, I can't stop there. Why? Well, I don't have to actually, I don't actually have to worry about age here, but I do have to worry about mean exposure, right? It's the effect of, it's the within person effect of exposure on antisocial attitudes when a person's mean exposure is at the overall average, right? And it's especially important to say that because I do have a cross-level interaction between exposure and mean exposure here, right? So in fact, if you look at this, I've got this cross-level interaction between the within person centered exposure and mean exposure, and it's 0.001125. Does everybody see that? So that's saying for every point increase in mean exposure, well, hold on, we haven't even talked about the mean exposure yet, but like I'm saying that mean exposure moderates the effect of within person exposure on antisocial attitudes, right? So that really means that this 0.268, that's only the effect of within person exposure on antisocial attitudes when mean exposure is at the overall mean. And conversely, or simultaneously, not conversely, but similarly, that's what I want. Similarly, when I look at the I mean exposure slope, 0.487, let's call it 0.487, the I mean exposure slope, that is what? That's the effect of mean exposure on the intercept, right? And again, really, and then, and probably best to say, when a person's at their own mean, but most importantly here, now we've got this exposure CWC times I mean exposure, right? And so now this is the effect of mean exposure on the effect of the within person exposure slope on the outcome. So this is that crazy cross level interaction, and it's positive. So that's saying that somebody who has higher levels of mean exposure, that the effect of exposure on antisocial attitudes is more, everything was positive here, yeah. The effect of exposure on antisocial attitudes, the within person effect of it, and I should say within person, the within person effect of exposure on antisocial attitudes is more positive. So it's steeper, it's stronger for people who have higher mean exposure. But it's not really. I mean, that's how we would interpret it, but it's not statistically significantly different from zero. So like, I'm over interpreting it right now just for the sake of making sure we know the interpretation. Yeah. Well, right, like we're again, we are allowing the effective exposure to vary as a function of mean exposure, but we haven't built in an interaction between time and the within person exposure slope. So we're actually assuming that the effect of the exposure slope is constant across time, which is why we don't have to say anything about time, really. We don't know because again, the way the model is built, we're really assuming that the effective exposure, the within person effective exposure on antisocial attitudes, we're assuming it's constant across time. We only have one coefficient for that. We're not allowing it to vary across time. So like time is like marching on, and we're predicting that as time goes on, that your score on antisocial attitudes is going to get higher. But that coefficient is after controlling for exposure, but really, we don't, but the exposure slope really is just one slope across all time. We're not allowing for there to be an interaction, so we don't really have to say after controlling for time, right? Like, it's like, because it's going to be the same across time because it's time invariant, exactly.
If
Because
we're time varying.
If we built in an interaction, oh God, help us, right? If we built in an interaction between time and the time varying covariate, then we'd be saying that the effect of time on the outcome variable varies as a function of what your time varying covariate is. And I mean, there are models like that, right? Like that could totally be. And then of course you could have a cross level interaction with like level 2 variables predicting, you know, not just predicting the main effects, but also predicting that interaction effect. So that's where, and then if you think about it, if you've got a level 2 variable predicting as a cross level interaction, predicting the effect, like predicting an interaction effect, the way to think about this maybe is think of that as like a 3-way interaction, right? Anytime you have a cross level interaction, it's a 2-way interaction. I mean, it's a special kind because, oh, is it 12 o'clock? Oh my gosh. Did we get to everything we need to get to? I think we did, kind of. Luckily, I only put the group mean centering stuff on this homework. Okay, thank gosh. Well, that means I guess we'll do discontinuity next week. So in my last thoughts here, now I totally lost my train of thought when I realized how late it is. Yeah, what I was saying is an interaction is an interaction. I mean, it's a special kind of interaction. It's a cross-level interaction, but it's still underneath it all, it's an interaction, right? And so if you have a cross-level interaction on, like, let's say you have a level 2 variable moderating the effect of an interaction, you know, like level 1 interaction, that's a 3-way interaction, right? So if you think back to like regression or you think back to ANOVA, if you've got, you know, a level 2 variable moderating an interaction effect at level 1, or if you've got the interaction of 2 level 2 variables moderating a level 1 slope, that is a 3-way interaction and has to be it has to be interpreted accordingly. Did you all do 3-way interactions in stats? No? Okay. Well, that's what it is. It's, you know, it's again, it's a moderation of a moderation. So, all right, any last minute questions before we call it a day? Homework is up. I think it's a relatively short homework. You don't have to interpret all the parameters in the models that you're running. It's like very targeted. It's very, very targeted on running a model, 3 different models: grand mean centered model, group mean centered model with the aggregate added back in, and a grand mean centered model with the aggregate added back in. It's actually the same data set that you used last week, but I got rid of all of the interaction stuff, and you're just focusing on the grand mean versus the group mean centered interpretations. And in fact, you don't actually, I think, have to interpret for this homework any of the tau stuff. It's all interpretations about the fixed effects. And it relates back to what we were talking about in terms of contextual effects before the break, and just making sure that you're interpreting the effects slightly differently when you're grand mean centering versus group mean centering. So it's a relatively simple model. Actually, it's a simpler model than what's in this output. And you're just really going to zoom in on just a few key things about interpretation of grand mean and group mean centering. All right, that's it. Have a good week, and I guess we'll do discontinuity next week.
Yeah.
Yes? Oh, probably, because I copied them.
I know, they're all printed, so I would.
Well, I won't do that, but I will go back in and I'll change them now for next year before I forget.
I did send you the email about this one, but no, that it's on.
Okay, cool.
And so the context effects, if there is an interaction, is still like gamma b minus gamma within, like if there is an interaction.
Yeah, I think one thing, when you get in it depends which interaction you're talking about. Like
the variable following this.
I mean, conceptually, this is still going to be a contextual effect, but as soon as you add in like randomly varying slopes, as soon as you add in interaction terms, then you're not necessarily going to get the pure mathematical equivalence between this and the contextual effect that if you like, when I was talking about like the grand mean centered model versus the group mean centered model and how you take this, and this will be the same as like the gamma for the level 2 variable. As soon as you put in randomly varying slopes, or as soon as you put in interactions, it's still conceptually, that's what we're talking about, but it's not going to be mathematically equivalent anymore.
So then for the context effects for the group mix, then saying like what the equation would be like. We need to add the coefficients. for
No,
the
no, it's,
interaction.
no, that's not what I'm saying. I'm just saying like, the pure mathematical equivalence between this and the parameter that you get under the grand mean centering level 2, that pure total equivalence is only gonna hold if you don't have randomly varying slopes and you don't have interactions. Once you make the model more complex, conceptually, it's still the same thing, but it's not gonna be like totally mathematically equivalent.
Okay, but for the contextual effects, it's still like this for the group mix centered.
For the group, yeah, this is still gonna be, this is still the contextual effect for the group and center model, yeah. Yes,
So that's, sorry.
I can't see what I'm asking, I'm sorry.
The last model on the homework.
Okay, use your best level 1 model from question 7, yeah, okay, so go back up to, so, and then, oh, well, maybe that's not the part you have a question about. Enter high school GPA and sex as predictors of the level 1 intercept and the level 1 slopes for jobs, hours, and wave, but not for the interaction. If, okay, so first thing is, if you have all of those things still
I still
in
have
there,
them all.
okay, so if you have them all in there, then what I'm saying is, enter high school GPA in as a predictor of the intercept. High school GPA is going to predict the job slope. High school GPA is going to predict the hour slope. High school GPA is going to predict the wave slope, but high school GPA is not going to predict the level 1 interaction.
So if it's predicting that slope, is that like a cross-level
Yeah,
interaction?
so that's what I'm saying. Cross-level interaction between this and this, and this, but not this, because this would be a 3-way interaction. So basically, I'm saying
Okay.
don't do the 3-way interaction.
Okay. Okay, that makes sense.
Yeah? Sure.
The example that you had on Monday. So am I doing this whole thing down here for each standard deviation question with the cross-level interactions? So like this was the example that you had, and then you talked us through the means,
Mhm.
and then you talked us through the standard deviations.
Yeah, so like if you had a standard deviation, so yeah, exactly. So if you had a standard deviation, if it says 1 standard deviation unit difference, then you'd be like, okay, well, what does 1 standard deviation unit mean? And like, yeah, so it's like 0.57 here, right? So then
Yeah.
you would put 0.57 is the standard deviation. Yeah, times the mean at like whatever the, right, whatever this is for the mean, right? Times the coefficient. So yeah, that looks right.
So, but then you had written all this out, and I'm confused if I'm supposed to use this one or all of these.
They keep scrolling.
Well, this is like all the different pieces, I think, of the models, right?
But I don't need to add, like, each time I do an interaction, I don't have to add like mean SES, standard deviation plus read.
So like,
standard
okay, yeah, so let's look
plus
at
the
it,
cross
okay, let's look at this. So like, this is just gonna be this,
Mhm.
right? This is gonna be this times whatever P is.
Yep.
This is gonna be this times whatever mean
Yep.
SES is. This is time to, so you're just gonna do, let's get to cross level. So when you get here, it's gonna be this times mean SES times reading 5. So
Yes.
it'll be, this will be 3 pieces. This will be 3 pieces. So like,
Yes.
this is mean reading times, so reading 5 is showing up here. Like here it's showing, like here's reading 5 twice, like it's showing up this times this times this.
Yeah.
And then over here, it's this times this times this.
But don't I need to convert, do I need to convert the number before I do the multiplication? If it's a
Yeah, yeah,
standard
like if,
deviation?
yeah, you're gonna, yes, you're gonna put whatever the units are in here
Yeah,
that you need. So like, if it says 1 unit, you put 1 in here. If it says 1 standard deviation unit, you put a standard deviation in here.
okay, but
okay.
it would, so it would be like 0.08 times the standard deviation times this.
Yeah, and so like, and if it said 1 standard deviation here as well, then this number is actually, like, I don't know if that was the question you were asking, but like, it's showing, this number's showing up twice, right? It's like this times this, times this, and this times this, times this, or maybe I'm not understanding your question.
I think that makes sense. I guess I'm just confused.
So like, I think that's what,